we've seen evidence for, in a past expedition, for a hydrothermal plume in this area, which was on a different density surface and hence believed to come from a different source from the Von Dam site that's to the east of us from here. Our best guess is that the target depth for the source for that thing should be around 2150 or so. So we're starting at 2300 today. We're going up to some hills, a series of topographic highs, all of which are shallower than 2200 meters. And that's where we're going to be spending the day.
Bridge now?
But for now, here comes the seafloor.
About 6.
So we'll be getting set up here. We'll drop
like
a marker before we move off,
to
just to make sure we know where we started the
position
dive.
the ship on the
And
right
looks
spot,
like we've
so
come down on
copy that bridge. I see
some of our favorite
2 meters
biogenic
to go. 2 meters.
carbonate.
Okay. Thank you, Bridge.
Mottling on the surface, the bright and dark contrasts, but of course we're still a long way high up, so we'll take some time to settle everything up and then bring the vehicle down and get a nice clear view of what's going on. Stand by. Okay, now this is watch lead. Once we get all set up, let me know and we'll drop a marker here before we do anything else. Oh, that's right. The Fighting 88 for any Tarantino fans. So just while we're setting up here, just give you an idea of what we're up to. We are at a depth of 2294 meters here with the ROV. We're currently facing west on a heading of 285 degrees with the ROV, and it's basically all downhill from there. Actually, if you look on the high pack, there is a lump over in that direction somewhere. But today's dive is all about going uphill, going east. So the first move we've planned for today is actually going to be going uphill. We're on a terrace which is one step down from the topographic high that's our target, the Europa mound, we'll call it, for want of a better idea. And the first thing we're going to be doing is moving 400 meters to the east and up a steep hill climb. So we're going to climb the best part of about 100 meters in 400 meters. It's an alien. What is that? Can we look at that lump? Zoom in on that, please, pilot. I see a shrimp sticking out from the bottom left corner. Is it a giant sponge?
Yeah, I think it might be a sponge, but I'm not really sure.
It's a bit murky, whatever it is. Nice bright red shrimp sitting next to it, though. I guess we're into our tether. If you swing round it to the right, Bobby, can you... It looks like there's more translucent stuff without the sediment or the base on the right-hand side. Okay. I'm probably...
There's a sponge not unlike this sort of shape that we get in the northeast Atlantic called Pheronema. Used to be called Holtensia after Holton, who was the governor of the Faroe Islands, and it's just named after him. And it's this sort of, shape, almost like a pancake, but I can't see the hole in the top. I would expect.
Very good. Yep. Yep. Thanks, pilot. That was great to have a look at. I now know what the name of the governor of the Faroe Islands used to be. How do you know all this stuff, Paul? It's amazing.
You can't spend time round Tony Rice without knowing such things.
2,000 meters, then a target at 2,300 meters for the source seemed a little bit too deep, so that's the gamble we've thrown. Is we've rolled the dice and we're going to go shallow, not deep today.
Clever stuff.
Nav, this is watch lead. So I think I just heard say you guys are good to go. Yep, let's start moving that way at whatever a suitably cautionary slow speed is, given the rough terrain. Understood. If you can let me know when we change speed, that'll be great. Yes, this would be great, please. Marker 88 right here. So this is it. It's the official start of the dive. The vehicles are all lined up, settled up under the ship. We have everything in harness, all ready to start our coordinated dance across the seafloor for the day. It is 15:18 UTC, 10:18 on the ship. Our vehicle is at a depth of 2298 meters. We just spun around a little moment to a heading of 225, so we're facing southwest at the moment, looking at this sponge on the seafloor in amongst the biogenic carbonate. And then we have put in a request for ship move, and then we're going to start moving across this terrace and up a steep hill. We basically have 400 meters run to the top of the first set of mounds we're going to be climbing up to, and we're going to be climbing just over 100 meters, more like 150 meters straight uphill. So it'll be interesting to see what we see, whether we're going to be seeing just sediment all the way, or whether this is going to be a steep enough scarp we're going to be flying up.
Is that good enough right there?
We're actually going to get to see some interesting rocks along the way as well and find out.
Can I request a ship move? 400 meters, bearing 110.
Chris, is that lots of gravel in the
please.
sediment?
Copy that. 400 meters, bearing 110
So,
at 0.2 knots.
That's correct.
Right,
Thank you.
starting now.
Nav, for my benefit, could you repeat that move, please? Thanks, Nav.
It's a very solid sponge.
Very good. Video, could we zoom in on some of the rocks just around the sponge? It looks like there's a lot of coarse, dark fragments here. Paul, the dark fragments there, can you get any idea of animal or mineral?
Well, I think they're mineral.
Yep. Is that a little polychaete sticking up vertically out of the sediment there? Interesting, some of those fragments,
Certainly is.
it's black, it's rounded, looks like it's got a couple of little holes in it. I don't know, video, if we can spin up, there's one above it on the left which is actually dark red rather than black, top center of the screen.
It's not sort
This
of
is a range in colours.
manganese coating, is it, on some of these things?
Could be, I don't know, there's grains, there's like things, there's ridges on that stuff. Who knows? Can we zoom out, please, and put some lasers on just to get an idea of the scale of those things? Get lasers on, please, pilot. Yeah. Okay, so those things are less than a centimetre across, but it's strewn across the terrace here. Okay.
It could be a function of the flow through the gap over this sort of saddle, Chris, that might be winnowing out the fine stuff
I
and
like
leaving the coarser stuff behind.
I like an idea. Mike Cheadle said that they're little spherical blobs of lava that's been exploded out of the seafloor.
I'm happy to buy that.
That's a nice story, isn't it? They don't have rabbits on the seafloor, do they?
Chris, you're not supposed to mention that word on a ship.
It's all right. It's not French. There's definitely, yeah, there's definitely, you can see in those, just to the right of the center there, it's a reddish brown color, but there's actually banding. It's almost like, it's like it's got curvature. Let's see, concave inwards. No. Yeah, concave inwards and concave on the outside. So like a lens, it's curving round from the top, say 12 o'clock, curving around like the top left quadrant of the face of a clock, round to about 9 o'clock. And you can see the curves from, it's dark on the inside, dark on the outside, and brown and red. Oh, maybe it's just, I don't know, manganese nodules might look like that if you crack them open.
It's not typical deep sea sediment as you would find on the slope or abyssal plain. It's much coarser, it seems to me.
It certainly seems coarser than the stuff we were looking at yesterday. But then we're sitting at the foot of a 150-meter cliff that we're about to drive up, so maybe it's just it's a grain size sorting effect that we're, you know, nature abhors a gradient, and there's a lot of stuff probably falling downhill towards us. Maybe this all looks a lot darker at first impression. Maybe it's just we're off at the end of our lights, but certainly, yep, coarser and more gravelly sediment than we're used to. Today at 20 meters off the bottom. Little Herc, of course, is down as close to the bottom as it can get to image the seafloor in as much clarity as possible for you guys watching at home and for me here in the control room. The great thing about starting the day on sediment is that we can actually get ourselves interested in absolutely anything else we see for the rest of the day. I hope you realize this is very sophisticated expectation management by us here in the control room.
I've
The
got it
offset
nicely
between
now.
the offset between ship and Sirius is probably going to stay about the same all day, and then Little Herc, using its tether, can then swim out ahead, see what's coming, and then when we do get to find interesting things like this fish just here, we have the chance to actually look at it with some quality time before we have to move on and catch up with what the ship and Sirius are doing. Pilot, do we have a little bit of time just to do a quick zoom on the fish? You might want lasers off, I guess. We can see it's about 30 centimeters long. Co-pilot, if you'd like to take the lasers off. Oh, it saw the lasers. Maybe. So then hopefully what we can do is actually keep the rock face right in front of us as we climb up today. And of course I'm saying rock face, it could be sediment face, but we're hoping this is going to be a steep enough hill that it's actually going to reveal itself to what it's made of. We've seen ultramafic rocks right down at the bottom of Mount Dent to the south. We've seen gabbros in and around the Von Dam area. And we've seen basalts up on the shallowest point where we were yesterday, and as we've moved our way up and over the top, we're now approaching from the far side of Mount Dent, coming in from the west. and working our way back up towards the shallower points on the mountain. Remembering that we're already at 2,300 meters here, we're at pretty much exactly the same depth now as the Von Dam hydrothermal field where we spent the first few dives of this cruise. So we're basically on the same contour. If you just stayed on this depth and just turned right here, if you stayed at this depth long enough, you would end up sitting right in front of a big white chimney covered in shrimp. That's a few miles away. It would take us a few days probably in consecutive dives to actually get there with the ROV at the speed we can move here. But it probably wouldn't take that long for an organism to get round here, so...
It was a rat tail, you know, macrourid of some sort, but there's a number of different species of those.
Okay. So a rat-tailed fish. Thank you, Paul. I see a rock. Let's go look at it. Or do you want to look at the worm? We can't. We'll get there. Okay. All right. Can we zoom on that little white thing you got right in front of you anyway? See what that is? Since we're already there. It's biology, but not as we know it. So what do we have, guys? Speak to me.
Not sure. Resolution's not brilliant on my screen.
One of those bamboo corals. It's a long white tubular thing. It's one elongate thing. It's about 1 centimeter wide. Who wants to say the magic word of the day?
Reserve.
Let's zoom in on it from this end, and pilot, just so you know, we're almost certainly going to want to look in the other end and see that it's a snapped off coral. But from... Oh, let's... No, that looks good actually. I'd love to be able to... Can we zoom in any closer and see if that's hollow on the end there? Looks like concentric...
That's hollow.
No, I don't think it is.
But I think it's a sediment grain tube.
Oh,
if
yeah?
you look carefully,
So it's a
I
filled
think there
in
might be
tube that's
sediment
liquefied?
outside. It could be...
Or broken off coral?
I don't think it's broken off coral. I think it might be a polychaete tube.
And how long is that? It's about 1 meter long.
Can we go close up on that bit that's there?
Yeah, let's zoom in there, please. It's shiny. Is this even biology? It's not just a length of something that's just lying on the seafloor, it's getting stuff clevered over
Looks as though it's incorporated some sand grains into the matrix of the tube here, so I don't think it's a tube worm.
As a biologist down here, I think it's a coral.
Yeah.
Dead, broken coral.
It's very shiny. Are corals normally that reflect light that well? It had almost a metallic sheen, like a mother of pearl or something to it.
Yeah, I guess the biologist here thinks some of them do, yeah.
Okay. So there we go. A piece of broken off coral. Certainly it seemed to be closed off at the end. It wasn't hollow. Very good.
Don't think we need to spend any more time on it, Chris.
Well, we can't move just now. Great. Let's go look at the rocks instead. An inhabited rock. So let's look at the rock first. That stuff under the lasers there would be good to zoom in on first, please. And maybe it looks like there's a fresh dark surface just below that. Okay, Bobby, what do you think you see here? Maybe we need to go down a little bit. There's a slightly grayer surface there with layers to it. Okay, I can see a crack running top right, bottom left in the middle of the screen there. I think the grayer stuff with the sediment on is better than the black stuff. The black stuff's manganese oxide coating, so there we go, under the lasers now and going up to the left, so bottom left quarter of this screen. No, end of our tether, I think. So having a quick look at that, I could see, well, let me see. Okay, first gut reaction is the thing it looks most like is the stuff we were seeing the day we went north and west from the Von Dam vent site. So I think I can see rectilinear faulting, and I can see angles, certainly sharp angles on this. And I thought I could see some layering and some fabric which goes from top right to bottom left. But let's have a closer look now we're set up. I guess that could also be, okay, that could be the end of a piece of pillow basalt, couldn't it? Could be that left and right is like a U shape and it's been cracked open upwards. Yeah, I think I agree with Bobby. It could well be that it's the... if we could pan out, please, zoom out. It's actually the stuff to the left we're really interested in. There we go. You see that right under lasers now. That thing we think could have been the top's been cracked open. It's actually the bottom 2/3 of something that would have been a tube coming out. Okay, zoom out a little, please. Right, that's it. Everything in the right-hand 2/3 of the field of view is the stuff we care about most. And possibly what we're looking at
Could we
is...
pan more to the left, Chris?
Sure. Okay, we have a request from the beach that maybe we can pan to the left, please, at this zoom. How's that, Bobby? Hold it there, please, pilot.
Now up a little?
And then if we can go up. Sorry, that's Jill, isn't it, talking to me?
Yeah, I'm talking to Bobby, but
Okay.
maybe, yeah, that looks good. We could zoom back out a little.
And then say again, please, Jill.
Could we zoom back a little bit?
Yep, zooming out. So that could be actually the pilot. If we could just pan right again, and that dark round surface to the right of the lasers, if we could just center up there, and then the bottom half of the screen, we'd like to look in on that. So if the thing we were looking at before is a tube that's had the top broken open, then the one to the right over the right laser now could be another pillow basalt that's been cracked open, and we're looking at it end on. So I can believe a story where these are basalt tubes or pillows facing towards us. And the nearer one has had the end cracked off, and also the top has been ripped off, and that's where you can see the exposed interior. The left laser would then be in the interior of the pillow, and you've got chilled margins to either side. Okay, thank you very much, pilot. That's enough speculating from me. Oh, actually, navigator, could we drop a waypoint here anyway, please? That'd be marker 089. I think that is, and just the note that from the serious view, somebody's reminded me that we can see that's clearly a boulder that's fallen down. It's not actually in situ or anything, so we've seen it. We think it's basalt here, which is useful to get our eye in for the day of what kind of rock types we think we're going to see.
We could zoom back out a little.
And then, say again, please, Jill.
Could we zoom back a little bit?
Yep, zooming out. So that could be actually the pilot. If we could just pan right again, and that dark round surface to the right of the lasers, if we could just center up there, and then the bottom half of the screen, we'd like to look in on that. So if the thing we were looking at before is a tube that's had the top broken open, then the one to the right over the right laser now could be another pillow basalt that's been cracked open, and we're looking at it end on. So I can believe a story where these are basalt tubes or pillows facing towards us. And the nearer one has had the end cracked off, and also the top has been ripped off, and that's where you can see the exposed interior. The left laser would then be in the interior of the pillow, and you've got chilled margins to either side. Okay, thank you very much, pilot. That's enough speculating from me. Oh, actually, navigator, could we drop a waypoint here anyway, please? That'd be marker 089. I think that is, and just the note that from the Sirius view, somebody's reminded me that we can see that's clearly a boulder that's fallen down. It's not actually in situ or anything, so we've seen it. We think it's basalt here, which is useful to get our eye in for the day of what kind of rock types we think we're going to see. And time to go look at the real stuff. No problem.
Are we at marker 089, Chris? Is that correct?
That's correct, MCR 089. And just plenty of soft sediment and no obvious targets just yet. There's a hint of something off to the right on Sirius, but it's beyond the reach of the tether of Little Herc, so I think we'll just keep going on this line and see what transpires. Silent running. Rat-tailed fish coming into view again. And you can see the twin shadows there from our twin headlights. It's really quite pretty. Synchronized swimming, practicing for the Olympics. And so, you know, if you look in the Sirius field of view right now, you can see that the reason we're hanging out just here is not because we're being distracted by the holothurian or the fish, but Little Herc has got out a good safe distance ahead of Sirius, so we have some time while we wait for the ship and Sirius to swing up underneath us, or underneath the ship rather. So take the time to scout around to either side and see what else we can see while we get some something dark there. Can we reach over to that pilot? It's like another boulder in the hillside. So we're on a heading of 175 degrees now as we approach this at a depth of 2276 meters. So we've come up 25 meters from the terrace now. And if we can get in closer to that or zoom on that. There are coral and shrimp hanging around on this piece of rock. Let's see if we can zoom in and see what the rock itself is made of. We were trying to look at the rock and see what kind of rock this is. So maybe straight up in that field of view, the bit just above the sponges. Let's try that for a starter. So it's dark. It's got 3 lines running through it. I think the lasers there, they're probably about 10 centimeters thick. So it's got they're running from sort of west-northwest to east-southeast across the field of view. It's got a lot of black manganese oxide on the outside where the biota are attached. Can we pan sort of up to the top left corner? It seems like there's some lines through that rock that are heading up in that direction. Again, this could be that we're actually looking at a cutaway section through a pillow tube. And is there more to the rock, or does the boulder run out as we go further up? Okay, let's zoom just there, please. Is that? Looks like people that believe this is pillow rubble. Lots and lots of biology. It's amazing how as soon as you put a bit of bare rock on the seafloor, how it gets colonized. Well, I guess not as soon as, it's probably been there a while, but even so. Okay, thank you, pilot. I think we can zoom wide.
There's a tube down there under that sea spider thing.
Approach this at a depth of 2276 meters. So we've come up 25 meters from the terrace now. And if we can get in closer to that, or zoom on that. There are coral and shrimp hanging around on this piece of rock. Let's see if we can zoom in and see what the rock itself is made of.
Is that light okay there, video? Okay. Watch lead, anything in particular you want to focus on? Shrimp, green thing, yellow thing?
We were trying to look at the rock and see what kind of rock this is. So
Rock it
maybe
is.
straight up in that field of view, the bit just above the sponges. Let's try that for a starter.
You got it.
So it's dark. It's got 3 lines running through it. I think the lasers there, they're probably about 10 centimeters thick. So it's got they're running from sort of west-northwest to east-southeast across the field of view. It's got a lot of black manganese oxide on the outside where the biota are attached. Can we pan sort of up to the top left corner? It seems like there's some lines through that rock that are heading up in that direction. Again, this could be that we're actually looking at a cutaway section through a pillow tube. And is there more to the rock, or does the boulder run out as we go further up?
Oh, there's more.
Okay, let's zoom just there, please.
Go ahead, video.
Is that? Looks like people that believe this is pillow rubble. Lots and lots of biology. It's amazing how as soon as you put a bit of bare rock on the seafloor, how it gets colonized. Well, I guess not as soon as, it's probably been there a while, but even so. Okay, thank you, pilot. I think we can zoom wide.
Video, could you do me a favor and quick zoom in, snap zoom?
There's a tube down there under that sea spider
That
thing.
little ball was. Okay,
Okay.
that's good, thank you.
Pilot,
Yeah, go ahead.
we heard from the beach, somebody thinks they can see a tube underneath the sea spider thing. So that's the sea spider. Yeah, what's that white thing there at the bottom of the picture?
Go ahead, video.
It had a plume out and it pulled it in just a few seconds ago.
So it does. We have ourselves a tube worm, we believe. And they think they,
Let's start at this opening.
pilot, so you know, people thought they actually saw the plume out just now and it withdrew just as we were approaching it. I was too busy looking at the rocks.
Zoom
Video, can you
right
go any
in on the
farther?
anterior end.
That's what we're setting up to do, Paul. Yep.
You are, okay. Come wide.
I don't
think
hear
it's
any.
a serpulid.
Say again, Paul.
It's a serpulid
Pilot, you're still
worm.
not directly below
Okay,
me. I'm
careful
just
with the
worried about
Ps.
if you'll be
It,
able to
and
rise
tell us about a
fast enough
serpulid
to
worm.
stay ahead of me.
Is that just something that just hangs out? Is it? Is
They
this?
have tubes as well. There's a lot of the polychaetes have tubes of various types. But it's just really worth looking at.
Okay. Pilot, we heard from the beach, somebody thinks they can see a tube underneath the sea spider thing. So that's the sea spider. Yeah, what's that white thing there at the bottom of the picture?
It had a plume out and it pulled it it in just a few seconds ago.
So it does. We have ourselves a tube worm, we believe. And they think they, pilot, so you know, people thought they actually saw the plume out just now and it withdrew just as we were approaching it. I was too busy looking at the rocks.
We zoom right in on the anterior end.
That's what we're setting up to do, Paul. Yep. I
I
don't
think
hear
it's a
any.
serpulid.
Say again, Paul.
I think it's a serpulid worm.
Okay, careful with the P's. And tell us about a serpulid worm. Is that just something that just hangs out? Is it?
No, they have tubes as well. There's a lot of the polychaetes have tubes of various types. But it's just really worth looking at.
Okay. Pilot, could we have a... Are we setting up to look at that even closer? Okay, thank you. And Paul, you're not whooping and a hollering, so I'm assuming this isn't anything to do with hydrothermal or chemosynthetic. This is just a kind of worm that happens to live in a tube. Is that correct, Paul?
Yes, and look at what I think you're actually seeing there. There's a pattern down the side of the tube. Can you see it on the
Yeah, it's got little...
side? Yeah, so I think it's a polychaete of some sort, but I don't think it's a chemosynthetic tube worm.
Understood. But still, if we don't find anything else today, we can say we dived on the Europa mound and we found some kind of tube worm. I'll take any kind of win today.
And a rather splendid picnic on it.
I was happy with the rock. Yes, I think so. Thank you, pilot. It's coming back wide. So, Nav, did I ask you to drop a marker there? And I think that should be marker 090.
Just heard from Ana Hilario, who's listening in Portugal, or watching in Portugal. She thinks it's a serpulid as well.
Great. And so those of you listening on the front row who can't hear on the EX line, we have confirmation from Portugal today. So it's another nation in our participation, confirming from our friend Ana Hilario that she too believes it's a serpulid. Thanks for that, Anna. Pilot, so you know, people thought they actually saw the plume out just now and it withdrew just as we were approaching it. I was too busy looking at the rocks.
We zoom right in on the anterior end.
That's what we're setting up to do, Paul. Yep.
I think it's a serpulid.
Say again, Paul.
I think it's a serpulid worm.
Okay, careful with the P's. And tell us about a serpulid worm. Is that just something that just hangs out? Is it?
No, they have tubes as well. There's a lot of the polychaetes have tubes of various types. But it's just really worth looking at.
Okay. Pilot, could we have a... Are we setting up to look at that even closer? Okay, thank you. And Paul, you're not whooping and a hollering, so I'm assuming this isn't anything to do with hydrothermal or chemosynthetic. This is just a kind of worm that happens to live in a tube. Is that correct, Paul?
Yes, and look at what I think you're actually seeing there. There's a pattern down the side of the tube. Can you see it on the
Yeah, it's got little...
side? Yeah, so I think it's a polychaete of some sort, but I don't think it's a chemosynthetic tube worm.
Understood. But still, if we don't find anything else today, we can say we dived on the Europa mound and we found some kind of tube worm. I'll take any kind of win today.
And a rather splendid picnic on it.
I was happy with the rock. Yes, I think so. Thank you, pilot. It's coming back wide. So, Nav, did I ask you to drop a marker there? And I think that should be marker 090.
Just heard from Anna Hilario, who's listening in Portugal, or watching it in Portugal. She thinks it's a serpulid as well.
Great. And so those of you listening on the front row who can't hear on the EX line, we have confirmation from Portugal today. So it's another nation in our participation, confirming from our friend Anna Hilario that she too believes it's a serpulid. Thanks for that, Anna. If we have the camera on the control room today, I'm going to wave to Anna. Hi, Anna.
Anna says hi on Skype.
Okay, so we are moving off, continuing upslope. We are now up to 2268 meters. So we have risen 30 meters since the start of the dive already. Vehicle is on a heading of 123 degrees for the Little Herc. Sirius is also heading pretty much the same way, 110 degrees. We are heading upslope towards the first of the different topographic highs, all around 2160 meters or so, the places where we're going to be hanging out most of the day. On the Sirius video, we can see there are rocks coming up on for Little Herc, forward and a little to the left. So top left screen on Little Herc.
Yes, do I see ripples in the sediment?
You might see ripples forward, but you're about to see rocks in the sediment.
I can see rocks now.
There we go. So this from the Sirius view looks much more like outcrop. This is actually what the wall is made of. Sponges on the rocks. See
Chris, it might be
faces
worth
in these things.
Chris, it might be worth waymarking the first appearance of solid, lots of rock.
Very good. So, go ahead, pilot. Yep, understood. I think we probably don't want to stop here today. We just want to get close enough to actually characterize what the rock is if we get the chance on the fly. Yep. Nav, could we drop a marker here just for the fact that this is the first time we've come to bare rock outcrop? And I make that marker 091. Can you confirm? Pilot, if we could just look at that large lump, the dark face. I'm not sure. Okay, and if we can maybe come up to the upper surface. I don't think I'm getting any the wiser. Okay, thank you, pilot. Let's keep you moving. Yeah. I'm hoping basically we're hoping for them. Could we just zoom on that little black thing right there? I think we can confirm that's a cracked open pillow tube, that rock just above the lasers. Yeah, just above the lasers right now. And stop that. Well, I want to believe that's looking in the end of a pillow, but there's like a flat layer of stuff just over there. Be hanging out most of the day. On the Sirius video, we can see there are rocks coming up on for Little Herc, forward and a little to the left. So top left screen on Little Herc.
Yes, do I see ripples in the sediment?
You might see ripples, Paul, but you're about to see rocks in the sediment.
I can see rocks now.
There we go. So this from the Sirius view looks much more like outcrop. This is actually what the wall is made of. Sponges on the rocks. See
Chris, it might
angular
be
faces
worth
in these things.
Chris, it might be worth waymarking the first appearance of solid lots of rock.
Very good. So, go ahead, pilot. Yep, understood. I think we probably don't want to stop here today. We just want to get close enough to actually characterize what the rock is if we get the chance on the fly. Yep. Nav, could we drop a marker here just for the fact that this is the first time we've come to bare rock outcrop? And I make that marker 091. Can you confirm? Pilot, if we could just look at that large lump, the dark face. I'm not sure. Okay, and if we can maybe come up to the upper surface. Oh, I don't think I'm getting any the wiser. Okay, thank you, pilot. Let's keep you moving. Yeah. I'm hoping if basically we're hoping for them. Sure. Could we just zoom on that little black thing right there? I think we can confirm that's a cracked open pillow tube, that rock just above the lasers. Yeah, just above the lasers right now. And stop that. Well, I want to believe that's looking in the end of a pillow, but there's like a flat layer of stuff just over the side of it. What do we think from the geologist back ashore? Can you tell anything from this stuff? It's so old, it's covered in sediment, and it's got the open dark surfaces are very covered with manganese oxide. Nope. Okay, pilot. Let's keep going. Thank you. And Jill, if Mike or Bobby see anything they particularly want to zoom in on, please do let me know.
Will do.
Thanks. Okay, that boulder in top left, can we just zoom on that? What I'd really love to see is radial textures. Oh no, don't worry. That's just sediment and rubbish. Well, not rubbish, but it's not going to help to zoom in on that. So
Yeah.
Pointing the right way most of the time.
Arabina
Just taking a
bridge.
back to 110. Go ahead, bridge.
Peaks are fine.
Yes, do you call bridge?
so we're
No, negative.
Oh, okay.
still heading
Sorry.
southeast. Little
Thanks.
Herc is
Thank you.
facing due south right now. Our depth is now 2250 meters. So we've climbed 50 meters from the terrace. We still have a ways to go. And actually, just that gives you a view there. We are looking across there. That was heading of 200. And we can see the hill sloping straight down. So I guess we were there looking pretty much straight along the that last view when we panned around to the right. That was Little Herc looking along the contours and gave you an idea of just how steep this hill is that we're climbing up at the moment. The time is 16:01 UTC, 11:01 on the ship. It's 12:01, just gone midday on the east coast of the United States. And this is Chris German in the watch leader's chair aboard the Okeanos Explorer as we're continuing to explore the Mount Dent part of the Mid-Cayman Rise, about 50 or 60 miles south of Grand Cayman, on an ultra-slow spreading mid-ocean ridge, broadcasting live from the seafloor using the ROV Little Hercules and its companion vehicle Sirius. Little Herc now is on a heading of 146 degrees, facing directly upslope. You see something here with something like 75% biogenic carbonate sediment cover with dark rocks sloping downhill. And again, we do see this sort of preferred orientation that when we do see rocks, they seem to be going from uphill to downhill, like the block that's right underneath the lasers at the moment. All of which one interpretation is that these are basaltic rocks. We're actually seeing are lavas which actually... And just so you know, what the pilots and navigators are discussing is they've been looking on the sonars, both on Sirius and Little Herc, making sure there's nothing particularly steep and cliff-like that they're going to have to encounter. We spent a lot of time on one of our dives earlier in the week when we were coming up from a much deeper depth, where we were over much more rocky terrain when it was this steep, but we have very much thicker sediment cover here, it seems. And all we see every now and then is a boulder like the one that's coming into field of view now. We see these little lumps of rock sticking out. They're either boulders or they're just topographic highs where the sediment isn't accumulating. You can't really tell from this view either way. You can see the sediment is so thick around the base of the rock you couldn't tell the rock had just landed on top of the sediment. But conversely, you can't prove it didn't just land there a long time ago and sediment's had so much time to settle since then that it's covered it over. The rock also appears very heavily weathered, so it's actually non-trivial to interpret exactly what the rock type is that I'm looking at here. Oh, that's interesting. Yeah, Paul, there's a green octocorals just there. Well, maybe we should ask for a... Paul, can you confirm those look like the same octocorals that we saw in the diffuse flow?
Only do, but all octocorals like this look the same to me.
I thought you hadn't seen green ones ever before.
Seeing them
Let's
for the second time.
So let's, yeah, let's. Do we have time to zoom around here without stopping the ship to just check out for any diffuse flow, or? Okay.
If anything, I would expect it from the other side of the rock, I think,
Yeah,
where the shadow is.
when we saw those before, Paul, they seem to actually be on the underhang of a rock that had water flowing up around it. So yeah,
Exactly.
I don't know whether we can come in from the other side. Our hunch, based on what the animals were, is that the water may be coming in up from the right. It seems like there's a step down. So the vehicle is now
Can we
heading.
get a marker here, Chris?
Yes, we will. We're just going to set up for the video. So we're spinning around from a heading of 240 through 165. So we were looking out to the west. We're now looking due south. Oh, actually, no, sorry, we spun all the way around. This is 114. We're looking southeast. Nav, can we drop a marker here, please? And if you could confirm marker number to me, please. Very good, that's confirmed. MCR 092 being dropped. We're on pursuit of trying to see if we can see any sign of any shimmering fluid. I don't see anything. There's the green octocorals.
I'm certainly not convinced.
Not convinced about the green octocorals, or not convinced about fluo?
Flow.
No, actually, just on that sponge, just if we can just go bottom of the screen. It may have just been the ship movement or the vehicle movement. No, if we could just do one more zoom on the sponge. I see nothing convincing. Can we just rise up a little bit and hold there? And no, I don't think so. Okay, let's move on. It was interesting anyway to see the green octocorals again. And that was marker 092. So we are continuing uphill. Now on a heading of 119 degrees with Little Herc facing uphill. It's now risen to a depth of 2239 meters. So we are 60 meters up from the terrace. And about half the climb that we need to make to get up to the top of the hill and the first of the bumps of our areas of interest for the day. And though this is quite a steep slope, but we are now, first we saw a few boulders, the order of a meter or so across, and then as we're progressing up slope, we're occasionally coming across areas where there's quite extensive rock exposed. And our best guess at the moment is certainly at least some of the rocks show strong evidence for pillow basalt, either pillows or tubes, some which have been cracked open, and plenty of organisms. Wherever we do see rock exposed, then we actually see increased biologic productivity or biologic activity and diversity. Holothurins as ever all over the sediments as we progress. And now we actually have a quite decent chunk of rock coming into view. So let's see what we're going to see here. I think, Nav, we're going to want a marker here, please, as we approach this. Go ahead, pilot. Understood, pilot. Yep, we're going to drop the marker here, and then we'll have a look as close as we can as we come by. Thank you, Nav. That's confirmed. Marker 093. A large area of what looks like outcrop. We see dark rocks covered in sponges. The appearance as a whole of the scenery is quite similar to what we were seeing up on top of the hill yesterday. We saw the same kind of animals on the rifts. Our heading here is 214 degrees. And again, if we look, I'm not sure if we can see it in the Sirius view. Maybe the co-pilot could just spin around to look at Sirius for a moment, to look at Little Herc. But I get the impression that this gap between the two lots of rock to left and right is very similar to the kind of width we saw in the rifts in pillow basalts at the top of the hill yesterday. Okay, unless there's any let's see if there's any particular requests from the beach. If not, I know we still have the ship moving. We don't want to dawdle here if we don't have to. But if there's anything you want a quick zoom, ask for it now. So again, we're on a heading of 236 degrees as we're sitting here, and a water depth of 2232 meters. From the 10 centimeter laser dots there, I would guess this is about 1 to 2 meters across. So the fissure again is about the same width as Little Herc. I haven't had any extra requests from the beach pilot, so I'm happy. Interestingly there, the orientation of the fissure, if it's along 214, is pretty much parallel to the side of the hill here, but slightly out from the fissures we were seeing yesterday. They were more north-south. This is more northeast to southwest. So, and now we're moving back on again. So Little Herc is going to get itself. So we have a little something white on the seafloor. Just zooming in to see what it is. Extreme close up. It's a piece of animal shell.
Looks like
It's
an
got
old
curvature.
Nautilus shell.
I was going to say it's got curvature to it. It's like a Paul's comment is good. It looks like a Nautilus shell for those who can't hear Paul quite clearly, but maybe you all can on the EX. Okay, so we are proceeding. The time is 11:18 here aboard the ship, 12:18 in Rhode Island, 16:18 UTC. Little Herc's depth is now 2223 meters. We're continuing our climb uphill at the start of this dive, heading towards the Europa Mound and the various topographic highs that we're going to find there. We're looking forward to breaking through the magic depth of 2200 meters today. We started on our terrace at 2300. We have reasons to suspect from chemical anomalies we've seen in the water column in the past that there might be something interesting up and around, well, the shallowest points we know in this area are around 2150 meters. So we're going to be spending most of the day investigating a series of mounds in that range of around 2100 to 2200 meters. But we're approaching cautiously from below. It's a very steep slope. We're working our way up to get to the top of the hill, and we should be there very soon. In the meantime, here we have further biogenic carbonate. Interesting marks coming downhill just here. Looks like, I guess that's where one of the most recent boulders may have run down, going by that. That's straight uphill. We're on a heading of 130 degrees. Nav, let's just drop a marker there. MCR 094 is dropped. We're on a heading of 142 degrees at a water depth of 2221 meters. And I wouldn't mind betting that's the fact that was heading straight downhill, that's the trace of where a boulder has most recently rolled down and let go from the top of the hillside. Might be interesting to follow that uphill, actually, pilot, and see how far we can go. Follow the gravel brick road. It's another one of these occasions where it looks like it's much coarser sediment inside that little channel than it is outside to either side. If we're really lucky, we've had some discussions earlier in the cruise about whether or not little scars in the sediment. Go ahead, pilot. Yeah. Okay, I'm afraid we really ought to go and look at the rocks. It's what I will tell you though, if we had kept going, that's where we would have found the sperm whale feeding just ahead of us, making that groove. Sorry guys, just going to tease you, but we're going to go look at the rocks. I was just going to say, we had been hearing earlier in the cruise that these little scars in the sediment might be due to sperm whale diving down to these kind of depths. They can reach to 2,500 meters in their dives and graze there, but let's go see what the rocks have to say. So I see kind of upper surfaces. This stuff seems to have an outer surface which is flowing downhill to the left, and then we have steps backwards, which are the flatter surfaces are covered in carbonate sediment. The broken surfaces have sponges all over them. So again, very similar to what we saw yesterday. Be consistent with basalt flows. Nav, let's have a marker here, please. And this should be MCR 095 going in. Thank you. We're on a heading of 097 degrees and a depth of 2215 meters. Actually, that's a good point. So from the Sirius perspective, this could just be a very large block. It's not even necessarily outcrop, although it looks huge in terms of what we can see in Little Herc's view. This whole thing may have just actually broken off and come down the hillside itself. Well, actually, no, that's actually a little ridge, isn't it? So it's actually, this is the end of a ridge, and that's, can we just get the heading there, please? If we could just spin back, pilot. Okay, thank you. So that all looks like basalt coming down here. So I wonder if that could all be one contiguous flow, because that seems to come out from the hillside. As we're heading there, that's 124 degrees. So it's pretty much heading directly uphill. So pilot, I don't know if we can actually come back down and actually drive back down the cliff face there, sort of reverse back and then descend. So basically what we can see there then is a ridge or a spur. There's a spur coming out from the hillside. It's covered in sediment. There's no break in slope there. That's basically an extension of the hillside itself rather than just a boulder. And then when we look at it end on, this whole thing, if you're looking in the Sirius view, Sirius is about 1 meter wide. So this is about a 5 meter wide and probably similar size tall. So is this 5 meters by 5 meters? Some nice rounded shapes. So you can see the sediment coming over there, almost like fingers coming out, like frosting on an English Christmas pudding. How's that for poetry in the morning? Must be getting close to my lunchtime. The pilot's like that. And so that rounding, about some tens of centimeters wide, that ought to be consistent with pillow basalts then. I have little else to say. Maybe we should let a professional geologist from the beach join in if they wish to. Or let Jill know if they come up with a better analogy than our frosted Christmas pudding.
No comment from the geologist on the beach.
probably ashamed to be associated with me after that discussion, that description. Could well be. Maybe we get to see both. Follow the sperm whale trail.
That is very impressive.
Rock outcropping. There you go, pilot. You're a natural. That sounds very good. Thank you. Yep. So we are one step over. We see another feature, and again in Sirius, you can see it's very similar in aspect ratio. It's the whole thing is kind of circular. You can see Little Herc in the middle of an area which is about 3 meters across, maybe. Again, we see sponges all over these things. Carbonate cover. Very hard actually to see much of the lithology, just because it's so heavily colonized. Pilot, could we zoom? There's a little bit just above your lasers, just there. I know it's got a lot of carbonate sediment on it, but it might give us a chance to look at the rocks. And you can see layers there. The lasers are 10 centimeters apart, so what you can actually see is going up the hillside there. There are cracks every 10 centimeters or so. It could almost be different layers of volcanic eruption, would be one interpretation, that it's been laid down one on top of another. Or it could be, I don't know, it looks quite big to be a single pillow with concentric rings in it, but I guess that's a possibility too. And pilot, there isn't any way we could actually look at the face and then get some idea of the orientation of where that came from, is there? Seems like if we swung on the Sirius view, looks like it's below you to the right. Which is the one we can see on the Sirius? Yeah, the whole thing as a whole. Yeah, sorry, no, but the whole block. We're trying to work out if this is another one, maybe the whole. So I guess we're trying to work out which way would we be pointing if we were end on to that. So that gives us a kind of view of that. That's yeah. See, okay. But your heading is 1, 2, 3 degrees, and you're a little bit oblique to it, aren't you? If you rotated to be parallel to that, going uphill right now. Okay, that's a heading of 127 degrees for the vehicle. Yeah. So I was thinking if you swung to your left to be parallel to that and got it lined up, and I would say that's getting closer. That's about 121, maybe another 10 degrees to your left would absolutely nail that. Yeah, that looks good. So that's a heading of 110 degrees, which is coincidentally where we're going, uphill. Okay, thank you very much, pilot. Let's keep the climb on. We're now at, and we are now on a heading of 1, 2. Sorry, that ridge was on a heading of 110 degrees, and we were filming it from a depth of 2209 meters. And now for a little bit of relaxation, we're back into biogenic carbonate. The time is 16:30 UTC. It is 11:30 aboard ship, 12:30 at our ECC in Rhode Island. Vehicle is at a water depth of 2207 meters. We're continuing our climb uphill, getting ready to cross the 2200 meter contour. We will eventually find an interesting lump when we get up to about 2160 and climb to the top of this terrace. Nav, this is watch lead. Do we currently have the ship stopped, or is it on one of its 0.1 knot moves?
No, it is still at the 0.1 knot move on transit to waypoint number 2.
Very good, thank you. Here's another one of these gullies, and you can see the light-coloured biogenic carbonate to either side. The gully is about 50 centimeters across. A lot of coarse sediment in there. There's a basaltic rock fragment. Pilot, maybe we can just zoom on that particular black rock just there. See if we can get any sharp faces on it. This kind of fits to our prejudice that maybe it's not a whale trail after all, that what we're actually seeing here are angular rock fragments, and that's basically what's causing these grooves in the hill slope. The beautiful view on Sirius right now showing you just how steep the hillside is that we're working our way up, and what we can actually see is basaltic material basically rolling down the hill. There's a slight yellow discoloration in the upper one of those two boulders there. If we can zoom in on that, that's when I start getting into wishful thinking that that yellowy brown alteration in the rock may be of some significance, but it may be biota on the outside. It's a nice crack actually you can see in the near field rock. You can see how there's concentric rings. So basically between the lasers there's a thing that comes up from the center left and bends around to the right, and then there's a curvature in there. That's all consistent with the pillow basalt, which had a chilled outer edge and a soft inside, and then the inside cools more slowly. The way these things erupt, that the lava it gets erupted into these blobs or tubes. The outside is in contact with the seawater and it cools instantly, and then the inside remains molten magma for longer and cools more slowly. And you get slightly more crystalline rock material. And what I'm not sure about from having looked at that rock, although it had the different colours, is whether the black may actually have been the whole thing is so old that the black surface was manganese oxide coating, and then the brown looked even newer than that, so it may even have been something algal or some kind of biota on the outside rather than hydrothermal alteration on the inside. But those are the kinds of colour differences we should be looking for as we look at these rocks. We're used to seeing a lot of dark black colours. Rocks that have sat idle on the seafloor for a long time, manganese oxide precipitates very slowly. It actually comes out, those rocks look even blacker than the exposed rock, if anything, just from the chemical precipitate from seawater. But it's actually iron is the thing that's more telltale that you're in the vicinity of anything hydrothermal. So yellow-brown discoloration is the stuff that we're actually going to be most excited looking for in any of our rocks as we proceed uphill. Here's another one of these spurs sticking out from the hillside. Thick sediment cover, but we're on a heading again of 120 degrees. So increasingly, as we're coming up the hill here, what we're actually seeing are these, the morphology is actually very similar. The very smooth rounded tops look just like the mounds we were driving over yesterday at the top of the hill. So we get these mounds which are made up of themselves internally, when you look at them in cross-section here, made up of individual blobs of pillow lavas, and they're all stacked one on top of another with sediment draped over the top. So we can actually see in Sirius right now, the aerial view, you can see multiple, what looks like the tops of multiple tubes, almost, the morphology, flowing down the hill. I can't quite tell whether that's multiple grooves through the sediment from boulders, or whether it's the fact that it's actually the rock underneath is actually dictating the shape of the sediment mantling over the top of them. And what we can see now is Little Hercus turned to face along 027 degrees, and we have more of this outcrop all the way along at this depth of 2195 meters. Okay, so continuing uphill, we should have about 30 or 40 meters to go till we get to something exciting at the top of the hill and we actually get to see what we have come to see today. But we've had a good steady start to the dive for the first hour and a half, approaching slowly from a terrace below. I think we're now perfectly comfortable that the main lithology over on this side of the hill are basaltic lavas. So again, very similar to the rocks we saw yesterday at the very center of the hill summit, and quite different from what we've seen further east and also to the south, where we saw gabbroic and ultramafic rocks respectively. So although the tectonics here is more complex than that, those are basically the rocks we've seen from deepest to shallowest on this mountain, coincide with classical theory of what typically one would find anywhere on the planet. Well, anywhere on that 70% of the planet that's covered by ocean crust, that if you actually drill down beneath the seabed, you would actually expect to come to basaltic lavas like the things we're looking at today first. That's what actually coats most of the ocean floor, beneath the biogenic and lithogenic sediments that wash in from the continents and that sink from the surface ocean. So you'd find lavas at the top, then down into gabbros, which are basically the same composition, the same bulk composition, but rock that has cooled more slowly. And then if you keep going down deep enough, you get into the upper solidified part of the mantle, and that's where you get the ultramafic rocks that we actually saw being outcropped down about over 1,000 meters deeper than we are today on our dive on Monday of this week as part of this same expedition. Okay, Little Herc is now on a heading of 155 degrees. We continue our move uphill, and we are now at a water depth of 2191 meters. We see more basalt outcropping, but mostly what we see here is still very heavy biogenic sediment carbonate cover on a very steep hillside. It's a great view. You can kind of see it now. We're looking along contour with Little Herc. That doesn't give you the full field of view, but if you look at this field of view from Sirius looking down at Little Herc, you see these huge grooves through the sediment, or huge lenses of sediment drape flowing downhill. And inside these grooves, every now and then we see coarse sediment, and on occasion loose blocks as well. Spectacular mountainside to be climbing up. But the climb isn't nearly as exciting as what we're going to see when we get to the top, I promise you. The view from the top of this mountain is going to be wonderful. If in your mind you could drain the water away, you'll be able to see for miles from the top here. But hopefully we'll have stuff to see much closer to home when we get there. So we're still proceeding uphill. Our general heading is we're bringing the ship and Sirius and Little Herc still in this heading of 110 degrees. We are still making our initial 400-meter move for the morning from a sedimented terrace up a hill slope, still with thick biogenic carbonate with outcrops of pillow basalt, and also occasionally some hint of other kinds of basaltic flow as well, but mostly pillow basalt, we believe. On a very, very steep terrain, we've climbed from 2,300 meters up to 2,185 meters. We've come up over 100 meters so far, and we have about 20 meters until we should come to the first terrace and our first waypoint, which is a mound at the top of this slope. We're intrigued to know exactly what might be going on with that mound and what the source of the mound is, but certainly it's consistent with it being something volcanic. We see pillow basalts on the way down, so it's always a good clue of what might be at the top of the hill. It'll probably be more of the same stuff that's falling down the hill from above.
Hey, Chris, when you have a chance, check out your email.
My email. Continuing up, something like 60% sediment cover here, with more of the rocky outcrop.
Just these bigger rocks in the private camp.
So we've come up about another 10 meters. We're now at 2176 meters water depth. And zooming out, you can see, climbing those contours. We've come up a long way. We have about 3 more contours to go till we get to the top of the hill. One last push, guys. And I think you can see again from the field of view from Sirius, we have the ship and Sirius heading up the hill, and Little Herc has managed to push out again, head again, using the availability of its tether to get significantly ahead, so we can actually stop here, take a quick look at these rocks. Again, I see a lot of rounded shapes reminiscent of pillow basalts. The same kind of thing we've been seeing all the way uphill. Vehicle depth now is 2174 meters. There's another block ahead. Actually, you can see in the Sirius the whole hillside is littered with these dark basaltic rocks. Some of them look like loose fragments on the surface, but then there are others like this one here look more firmly embedded. A spectacular cliff face to be climbing up. And something that's interesting me here is that when we saw a lot of, I guess it must be a time of the longevity of how long this stuff's been around, but on this side of the mountain or on the basaltic rocks, every surface, every rocky surface we see has been colonized extensively by sponges. I don't know how long they take to colonize a bit of rock or how long they take to grow, but clearly there's been enough time for that to happen here. Whereas I get the distinct impression that earlier in the cruise when we were further east and deeper, when we saw bare rock, we spent a lot less time looking at these kinds of organisms colonizing the rock surface. We've had a report from the beach that we can see some green corals here. There we go. There we are. These are the same octocorals that we saw once earlier today. And we'd also seen them once at the end of one of our other dives in an area with active diffuse flow. And look, we see the white corals just there as well, adjacent to the green ones. We have the white ones in the bottom right of the picture and the green ones in the left. Paul, if you're listening in, would you like to give us a quick running commentary of what we're looking at?
Yes, the ones you can see in the picture now look to me like Alcyonians. I think Santiago said earlier on the stolonifera are connected by what look like stolons, little tubes. But the Alcyonasians actually have a mass of tissue which you can see right in the middle, and the polyps retract back into that tissue. I think that's what's happening there. Look, it might be stolons, seeing the way they come out there, but there's a large mass of what's called coelenchyme that the polyps sometimes can retract into. Very nice video.
Thank you, Paul.
Santiago and Diva have just confirmed they think it's Alcynasians as well.
Thank you. Okay, let's keep moving on. Thank you very much for that. Okay, picking up and moving on. Hope you enjoyed the video at home. So, we're going to continue our move south and east uphill. Can you confirm our distance now to the E2 waypoint, please?
Yes, we have approximately 100 meters left of ship move, and then the ROVs will probably land just shy of that.
And an ETA for that? Is that about another 30 minutes or so?
Yeah, approximately 30 minutes.
Very good, thank you.
Yeah, 32 minutes.
Can you repeat that, Chris?
So we are 180 meters from the top of the hill and our first prime target for the day. It's going to take us about another 30 minutes to get up there because we're having to proceed slowly to cope with the topography. If everything goes to plan, people, so you know, listening at home, this could work out perfectly once again. The first half of the dive will be me in charge, taking us to somewhere new and spectacular and exciting. And then I can get out of the way and let Paul tell you everything about what it is we've just discovered once he comes on at 1 o'clock. That's what he's here for. So proceeding uphill, the water depth now is 2168 meters. We are proceeding uphill to the southeast. The RV is currently facing due east. Some hint that we're coming to the top or of a little shoulder here. A little bit of flattening out. We can actually see horizontal sediment. First time we've seen that for a while. A little local terrace. So anything interesting on the sonar? Not just yet. And so you know what we're basically doing, folks, is we're taking a line that's going to go straight uphill to get to the E02 target. And then we actually have two locations northeast and southwest of each other at pretty much the same depth along that terrace. So we're basically going to come up to this first terrace, check out what's going on there. It looks like a couple of small mounds in our multi-beam bathymetry that we've collected from the ship since we've been out here. And then what we'll do is then step up to a higher terrace, which will be the shallowest point we get to today, and see what we find there. Can we just look at these rocks down below us, pilot? Do we have time to do that? So this is now, we're on a heading of 041 degrees, so we're looking northeast along the contour, and what we can actually see is this ridge is quite a jagged ridge, so it's sloping downhill smoothly to the left, broken upward on the right. If we could have the lasers on for a moment, please. Co-pilot, can we have lasers on, please? Oh yeah, they're there, sorry. So the looking off into the distance is about a meter wide. And pilot, if we could just step to the right, I'm interested in trying to get a view of the gully that's to the right of the rocks. Yep, if I didn't know better, I would think that that could easily be another one of these meter-wide rifts, because the rocks seem to have been broken open. They're vertical on the right-hand side of the rocks. That's good. If we could just spin left a little with the vehicle, please. So we're looking along. That's great. So what you could imagine is that there's a rift there. The rocks on the left have been ripped, so they have a straight up and down fault on the right. So that'd be consistent with a rifting on a heading of 038 degrees. In fact, it actually, maybe it curves around here.
Hello, Chris. What is the orientation on this feature here?
It's 038 is our heading.
Okay, thank you.
Yep, very good. Thank you, pilot.
Could we drop a marker here?
Sure. Nav, could we drop a marker there, please? And if you could confirm marker number. Thank you. Here's another one of these gouge marks we've got very used to looking at. Pilot, I wonder if we could just spin long enough to get the orientation of that gouge. To look along it. We are now at a depth of 2155 meters. The vehicle is facing along 212 degrees right now. Thank you, pilot. That was enough of that. It's another one of these scour marks we see in this biogenic sediment. We have coarser grained sediment in the bottom of these scours. Not quite sure what they are. There are things similar to that on the steep slopes where we could see they were caused by boulders rolling downhill, but on this relatively flat surface, all we tend to see, and we've been seeing them all cruise, scours in the sediment with coarser material left behind. in other parts of the dives elsewhere. We haven't seen those yet today. We've actually seen circular holes in the sediments as well, the order of a metre across. Again, with coarse-grained material at the bottom. We think they might be related to fluid exhalation. But the other attractive interpretation of some of these more elongate scars is that they're the same shape and size, or they match to the dimensions of a sperm whale's jaw, and that they may actually be a sign of sperm whales diving to this depth and grazing along the sea floor, apparently. And pilot and co-pilot, if you can hear me, it seems like is that something real showing up on the sonar on Little Herc just ahead? So we have a large rocky outcrop here on top of the hill. There's a big hollow actually that it's sitting in. There was a coral off to the right. We are at a water depth of 2154 meters. We're on a heading of 055 degrees. And the view from Sirius looking down on Little Herc, you can actually see that this again is something that's about 5 meters across, or 3 or 4 meters across, maybe 5 meters high. Oh, in fact, that's probably a rift. I think what we're looking at here, this is very similar to the volcanic mounds we looked at yesterday. Nav, let's drop a marker here, please. Very good, confirmed, marker 097. Pilot, what I would like us to do, if we can, I think either side of the hill here, a little rift. So the one that's just in the bottom right of your view now, and I think there's one the other side of the hill as well. So if we could just get ourselves lined up with one of those and have a look inside it, well, a look over the top of it at least.
If you pan down, Chris, there's something white in that crack.
Yeah, I think that's a sponge in the...
It's a sponge? Okay.
But if we could pan down maybe, I'm not sure, or bring the vehicle down to have a look. So our heading right now is 060 degrees. This again looks like one of these rifts of the order of less than a meter across through a volcanic ridge. And I think, pilot, if we get the chance, can we just move ourselves laterally over to the left and look the other side of the ridge, or are we out of time? Can we jump up over the hill that's sloping uphill to the left? I think there's another one of these rifts over the other side as well. Okay, or maybe we can have Sirius just spin a little to the left and light up the other side of the ridge. I know we can't move over there, but I'm pretty sure I saw the same kind of crack on both sides here. Actually, yeah, if you just lift it up, you might be able to light it up as well, so that Sirius can see it. There we go. Look, there's another crack through the rocks there. Very heavily sedimented here, though. I think this is a bit from the shadow you can see now as you're lighting it with Little Herc. In the Sirius field of view, you can see the shadow it's casting, but it's a deep gouge through the rock there. If we could just possibly get across and then line ourselves up just to get the orientation of the crack, that would be great. There we go. Beautifully done. Keep coming a little right further, please. I don't mind the crack getting out the field of view. I can keep my heading of where we're looking, so keep spinning right. A little bit for that, looks pretty good. And that's on a heading of 071. If you brought the Little Herc to 060, I bet that would be... There we go, perfect. Oh no, that's... yeah. Okay, 071 I think was the best heading we got on that. Thank you, pilot. But yeah, So that's good. We're seeing more of the same kinds of features we saw yesterday then with these mounds of pillow basalts apparently with cracks running through them the order of about a meter wide as these things get rifted apart. We are now at a depth of 2150 meters, so we still haven't quite finished climbing. We're still on our way to E02, moving at a speed of 0.2 knots, and we're now back over biogenic carbonate sediment. Actually, I've deceived you there because I had the pilot climbing over the top of a mound. Although the vehicle's at 2149 meters right now, it's about 5 meters up, so the actual water depth would typically fly closer to 1 to 2 meters off bottom, so just coming up to about close to the 2150 meter contour.
RV Nav Bridge.
Go ahead.
Hey Brian, I'm going to be raising up the bath thruster so that the engineers can do some work on
What
it.
are those mounds? What are those little holes on the
I
right,
have
pilot?
12 meters or 11 meters left in this move.
That's probably not a direction we can go
so
to,
I'm just going to finish this move, then come to a stop, raise it up. I'll let you know when it's up.
Copy, thank you.
Okay.
Sure.
Okay, just lit from a different angle. They just looked darker or something. Okay, yep. This one just as you turn left there, I think. I think there's one we're going to come right over the top. There we go. And there's one right in front of us. Can we just look in the bottom of that little scow right under you just now? There we go. Just want to check it's the same coarse gravel we've been seeing everywhere else. There's nothing different here. What's our camera angle right now? Is it horizontal or we dip down?
About 45 degrees.
Oh, okay.
Do you want to try zoom right here?
It's very similar to the coarse material we were looking at right down the bottom of the terrace, wasn't it? Okay, thank you very much, pilot.
Nav's Bridge. We're all stopped and the bath thruster's coming up.
And let's complete our move to E02. Thanks, guys. So there we go. So you guys in the front row know we've just finished the traumatic hill climb, which is going to be the hardest part of the day for you guys, I hope. And we're flying around on this terrace and maybe just going up a little bit shallower in an hour or two after we've checked out what's on this area, but we should be staying within about 5 meters of the same depth while we check out 2 or 3 lumps in this vicinity. And navigators, watch lead. Yep, I think I can already tell at a glance that we probably won't want to hold the ship up too long here. I think we can probably, if we can bring ourselves through the E2 segment or waypoint, there's nothing I can see on the sonar that's obviously going to attract our attention, I think.
That's fine. Do you mind if I catch the ridge area you were talking about after E3? I think it's more in line with E3 to E4. So we can go E02 to E03, catch that little bump that you were just talking about on our way to E04.
That's absolutely great idea, thank you. And I'm looking on the Sirius sonar, I can't see anything at that level that looks like it's anything interesting to look at here. I think this may just be a terrace with some undulations and flat sediment. So I think what we're going to do is we're going to pass through E02, but there's nothing here to attract our attention. Nav, when we think we've got Sirius and Little
Nav,
Herc
bridge.
at E02, if we could drop a marker there, and then we'll move straight on to
Sure.
E03, please.
Sure. Go ahead, Bridge.
Yeah, tunnel, the thruster's up, and we can continue operations as normal.
Copy that. You ready?
Yep.
130 degrees, or excuse me, 130 meters, 230 degrees, 0.2 knots.
130 meters, 230 degrees, 0.2 knots. Starting now.
There you go.
Wow, man, you got to make us go directly on the beam for our first move after the tunnel. The thruster's up. Man,
Yeah, I did it just for you.
you're really good to us.
I am.
Really
I know.
good. You know, I almost wish you were still sleeping.
Thanks.
Alright, pilots, the next direction of move is 230.
And Nav, this is Watch League. Can you remind me the distance to E03, please?
130 meters.
Very good, thank you.
What is this marker number, please, Chris? I'm just back.
And
Ship stopped yet, man? Or are we continuing? 'Cause we are underway towards 230, so you're going to get a little bit of swing, but the ship did stop for just a minute to change its heading.
and Nav, are we ready to drop that waypoint here, marker here? Or did you do that already?
No, thank you for the reminder.
So that should be, I believe, MCR 097.
098. 097 was that last rift we just looked at, is what I have.
Okay, thank you very much for that correction.
And the correction was?
It's MCR 098, and we are just passing through our navigation waypoint E02.
Thanks, Chris.
MCR 097 is the volcanic fissure.
Very good, thank you, Jameson. So, we've completed our hill climb, we've seen biogenic carbonate, and we've seen pillow lavas. We've made it to the top of the first of two terraces. You can see in our high-pack navigation, we're on the Ferrari red section, and we'll be heading up to the more crimson hilltop later in the afternoon. But what we're going to do for now, before we go any further, is we're going to stop here, give the pilots pause for breath, because they've been climbing uphill all day. Take a view, look out over the valley, enjoy the scenery from this far up the mountainside, and then drive southwest along this terrace from one end to the other, just to make sure there's nothing particularly exciting up here we should get interested in. And then what we'll do is, when we get from E02 to E03, we will head southeast once more and head pretty much straight uphill to the top of the summit at E04. And what we'll do then is, again, we'll then drive along the top of that ridge and checking out all the different topographic highs to see if there's anything interesting we can find there. The reason we're in this area is that when we did some CTD work in 2009 and collected water samples over here, we found distinctive plumes, we found interesting microbes as well as chemistry in the water column about 100 meters shallower than the depth that the vehicle's at right now. It was just slightly shallower than 2,000 meters. This was one of the obvious places that was shallow enough to be the source of that material. We've had others and objective eyes that weren't involved in the program go back over all the data from that cruise as well as this cruise. Sarah Bennett from the NASA's Jet Propulsion Lab in particular has been going through both sets of data that we have from here and 2 years ago. And we have pretty strong evidence that the two sets of plume signals we've seen in the water column at Von Dam and in this area are different from one another. So that what's intriguing is that potentially there's a second source of chemical expulsion into the water column over this side of the hill, and that's what we're looking for today. And Nav, was that you saying you saw a target off to port in your sonar, or one of the sonars?
But they are chasing it down.
And that's the target you can see at about 40 meters out from Little Herc sonar?
Yeah, 35, yes.
Very good. So we are currently proceeding towards a hard target on our sonar. The vehicle is heading a direction of 180 degrees, and it's a little bit off to our left, so that's basically to the southwest from here. The general trend of the move we're trying to make with the ship is to the southeast, but we have the ability with little Herc to actually fly out to either side as the ship and Sirius move down our survey line. And our range, the concentric circles on the little Herc are 12.5 meters. That's about coming up to 15 meters ahead of us. It's quite a bright target, and nothing to either side of it, so it's quite narrow as we get closer. It's quite a narrow beam that's picking up the bright yellow and red returns. Happily, not only are we heading right towards it, but the pilot's getting little Herc right out in front of Sirius. We'll have some time to stop and look at it, whatever it may prove to be. It's coming into sight on one of the pilot's cameras. Should be in your field of view very soon. Should be in my field of view very soon. And we have a little bit of rock. And you can see compared to the 10 centimeters of, doesn't have to be very much rock to shine up on the sonar around here. Looks pretty old, very heavily weathered rock. Yeah, can we look down to the bottom right corner, just make sure I wasn't hallucinating about some shimmering flow in that dark crack in the corner there? I'm sure there can't be, because there'd be a lot more biology around here if there was, but I can't believe there is, because nope, that's good, thank you. That was the freshest looking crack as we approached. I just thought it was worth checking that out. Thank you. Let's drop a marker here anyway, since it's the first piece of rock, bare rock we've seen actually up on top of this hill. And that should be MCR 099, I believe.
Actually, co-pilot, based on the scattered returns going out on Little Hut sonar, it may be the top edge of the ridge that's just barely exposed.
Very good, thank you. Can we get an orientation of that ridge, do you think?
Yeah, it looks like it's bearing almost due south.
Thank you.
Looks like we got a lot of big coral strings in this area as well.
Okay, let's look at the coral. If you think you can see. Yeah, let's have a look back at the, what else was on that rock? Looks like this is the way we're going to be going anyway, right? And remembering that although the corals themselves aren't anything to do with hydrothermal activity, we have had the good fortune that they've been a good guide to where life's happiest in the past, which has also coincided with fluid flows. So looks like there's actually a crack running through these things, doesn't there?
Chris,
so we're
this looks
facing
like
175 at the moment.
This looks like the site that's to the southwest of the spire that we went to, and we saw a little bit of fluid flow there and some dead Gorgonians.
Quite so, Paul. I think, pilot, if we can actually, don't know if we can actually move forward, but spin a little to our right. I can almost imagine there's a crack that lines up between the two largest corals. If we could fly a line to the left of those corals and look into that crack. And that's vaguely the direction we want to be headed anyway, right? Okay. Yeah. I would like to fly over the crack to the left of the corals, yeah. So yeah, I guess that's it. Use them as the alignment. But you can see that fissure. What I'd really like to do is actually look down in that fissure that's at the bottom of the screen right now. You see the dark shadow there in the rock? What's that bright pink thing there? Can we? Let's have a look.
I think it's a small gorgonian.
Okay.
Would you like to look at that pink thing in more detail?
Yeah, if you get the chance.
Okay.
And basically what I'm seeing here is not only just the cracks running through the rock here, the rock is aligned the same as the ROV, so right now we're on 220 degrees. There's cracks running through this rock, there are corals and other organisms living along the line of that crack, and you can see the crack then propagates actually through the sediment. You can see the sediment running off to the right. There's a groove in the sediment.
Okay, buddy, I'll try to stay put here. And then next time.
So I'm keeping my eyes peeled, no sign of any active fluid flow right now, but I could believe if that was a lava tube once. Oh. My eyes are playing tricks on me crazily today. I keep wanting to see fluid flow.
I lost it. Okay, full wide view.
And how about just above the left gravel spot? Just there, left laser. Nope, time to move on, is it?
I'm not seeing any flow from video.
Nope, I was just looking in that little pile of gravel. I was trying to remember from when we saw the, as Paul said, when we found that area, the first area of corals we found just southwest of the Von Dam site. It was only when we stopped to look at the corals that we found the fluid flow, so sometimes it was in the coarse material, but this looks pretty heavily sedimented. This probably is the occasion where it's just the rocks are providing a change in substrate for the corals
Should
to
we
take
take
advantage
a
of.
zoom here on the live thing? Just down.
Pilot, can we zoom down on the corals we just went past? I believe it was the corals. Can you repeat that, Jill?
I should have just.
Yeah, it was the corals that we just passed that were in the center of the screen.
Okay.
We've almost lost it pretty fast southeast.
I think we're struggling here with the what we can do. I think it's that coral just down to the right of the lasers.
Yeah, there they are right there.
Just there.
The live corals in the
If we
center.
could. How's that for OSEC?
Good, thank you.
Okay, thank you, pilot. Guys on the beach are happy with that. Oh, I tell you what, if you just pan down, there was yellow alteration in that rock there. I'm very sorry. Alright, but I definitely saw yellow alteration in the rock just above the sediment. Just down to the right of your lasers right now.
That's funny, my camera ran away. Alright. The yellow you saw is something living on the rock.
Oh, it is? It's something actually living on the rock?
Yeah, it looks like
Okay.
a biologist. Okay,
Yep.
the setting. 230 Carl. 230.
Okay, let's go find something good. Moving on. We are on a heading of 251 degrees. Heading out over the lunar landscape, lit from above. We are on a depth of 2145 meters, moving over 100% biogenic carbonate sediment cover. There's more of these grooved and pits in the surface of the sediment.
There's only about a 10% chance that will.
It's a beautiful shot in a series right now of Little Herc coming into view and catching up and getting back out ahead of us, or getting back ahead of the ship.
Pretty nice shot. It's like I'm coming to the edge of something, huh? Yeah, sort of a big hole. Big hole.
Is that a circular hole? Or is it just the edge of a cliff?
It's an oval circular hole.
Wow, how big is that?
Quite large.
Much bigger than you, right? I can just see the far side, I think, in your lights. And we're going to go over that with Sirius in a moment, right? So we'll be able to get an idea of just how big it is.
Check out the bottom.
Can we go look? Looks like there's some rocks exposed on the far side. Or something dark across the way.
Yeah, definitely. Yep, some rocks.
So this is a huge hollow. This is much, much bigger than the ROV itself, I think. In fact, you can see there. Oh, this really is like a lunar crater. Nav, I think we better drop a marker here, please.
I'll check out these 099.
Thank you very much.
Bottom first, and then I can check out the rocks on the other side.
Sounds good.
You're not gonna have a whole lot of time to see us run directly over you. Okay?
If I have to choose one or the other, we'd like to look at the rocks, please.
Alright, we'll do those first.
And then from size, that's, let me think, about a 5-meter diameter?
And as the cricket commentary would say, that brings up our 100, and I think that's a wonderful innings for Mr. German.
Is that, let me just check that. Nav, which number marker was that, please?
099.
We have marker 099, actually, Paul.
I get 099 back at 1820.
Yep, I have that as well. Let me check with Nav. And Nav, we believe we dropped MCR 099 at 1720 UTC.
You are correct.
So this is MCR 100.
Centennial.
There we go.
Nav, Rich.
Well called, Paul. This is MCR
We're
100.
19 meters away from the end of this move.
Yep.
Nice.
If we could zoom in on the rock itself, just to see the lithology. See if it's anything different from what we've seen elsewhere today.
Beautiful little stalk sponge.
I'm not sure if we can see anything. Let's see if we can look up a little bit, please, onto the darker material. Okay. Yeah, looks like the. Mm-hmm. And I'm trying to see if this is still basalt. There's so much sediment cover, it's hard to tell. If we could maybe pan round to either side before we get to the top of the crater lip. Or maybe we need to zoom wide again. These could almost be layers of float. Well, I'm not really not sure. Looks like quite a granular surface, but it maybe just be so weathered. Okay, maybe we should back off and have a actually look at the inside of the crater as best we can. Is it actually circular, or was it just it was a hole on one side? It looked like a 5-meter wide sort of circular hole to start with, but. Oh, okay. So it's in the lee of the rocks. It's just hollowed out. Okay. So the strike of the rocks, so Sirius right now is facing 220 degrees. So that's basically a north-south. The line of rocks you can see in the Sirius field of view is running off, I believe, must be running off due north-south.
Chris, could we zoom in on those sort of foliated-looking rocks? I guess just to the right of center.
Okay, pilot, we'd like
just above the lasers.
We'd like to go just above the lasers and a little to
the right.
I think just there, stop there. And we'd like to zoom in on those layered rocks, please. Yep, very good, thank you. So we're going to zoom in on those rocks In the Cirrus view, you
To
can
the
see
right.
a little to the right, please, pilot. Keep going. Actually, it might be the rocks all the way around, about halfway to the end of the field of view to the right. Just above that big platy surface, and then up above that, there's some dark rocks.
Yeah, right up above that.
Yep, okay, we're going to fly over that, and that's going to be the last thing we do before we have to move on. Definite distinct layering there. What I'm also seeing is the way that Sirius is heading right now on 222 degrees, this stuff heads off. Looks like these rocks are exposed because things are dropping down to the left, which must make it, I'm trying to do the mental arithmetic in my head, we're facing south. Drop down to the left, so it must be down to the east.
Nav, bridge.
Good.
Yeah, we're all stopped.
Ship moves complete.
There's layers there. The layers are probably the order of 1 to 2 centimeters thick. The whole block there is maybe 50 centimeters top to bottom in that field of view. Sub-horizontal layering, panning slightly down from left to right.
Thanks, Chris. That was really helpful.
Very good. Okay, pilot, thank you very much. The guys on the beach found that very useful. Now let's get back on with the program. Go ahead, Nav. Thank you very much. When we get the vehicles there, we'll drop another marker. Yep. This is interesting. I mean, let's have a look at the little one first, because that's the kind of size and shape we've been seeing in lots of other places on this cruise. We've been seeing these little depressions like this. They're about 1 meter across or so, maybe a couple of tens of centimeters deep, with sort of coarse sediment in them. And then if we do have time just to fly over the one off to the left, that's enough of that one. So that's things we've seen before, but we still don't understand their origin. And now on this terrace, we've seen a couple of much bigger things. I guess it's going to be outside the Sirius field of view this time. We're currently heading 133 degrees, depth of 2146 meters. So intriguingly, we're actually facing, in the bigger scheme of things, we're facing uphill right now. The top of the mountain is the heading we're going on now. This is where we're going to go when we leave EO3 later. And so it looks like we're facing uphill, but it must be a gully coming down from the general uphill direction. Curiouser and curiouser. Oh, sorry, I'd asked Kelly to put lunch out for me. Okay, watch lead nav. So did Sirius pass through the E03 waypoint? Okay. Very good, thank you. When we are settled up there, I'd like to drop a marker before we move on to the next waypoint. If you could let me know when we do that, and I'll enter it into the log. Thank you. We are now at a depth of 2145 meters. We're on the top of the terrace at the southwest end of a terrace, one step down from the top of the hill here on the so-called Europa mound at the bottom of the southwest limit of Mount Dent. We are just letting the vehicle settle up underneath the ship. We've been heading southwest along the top of this terrace, or along this shelf, and what we're getting ready to do now is to then strike out in a southeasterly direction again, back uphill, heading up towards E04 and the summit of this corner of Mount Dent. And Carl, are we ready to drop the marker now? Sorry, that's not Carl, is it? Very good. Marker 101.
Go ahead.
130 meters, 110 degrees, 0.2 knots.
130 meters, 110 degrees, 0.2 knots. Starting now.
Thank you.
Well, there we go, folks. My hunches were that it was going to be one of these little mounds on this terrace was going to be the place that was going to provide us all kinds of hydrothermal excitement today. We're now heading towards E104. Actually, one last interruption. Nav, if you see where your cursor is on HiPAC just now, what we would like to do is to be able to drive the ROV through that point as we go up to E04, please. That's perfect. Thank you very much. So
RV
yes,
nav, Rich.
there was one grand interpretation I had of the world where this would be this terrace would be stuffed full of hydrothermal mounds at the base of the cliff we're heading towards just now. So I have one last chance to pull it out the bag.
Sure,
If
no
not,
problem.
we'll be up to the tops of the big hills, which are the ones that our geoscientist friends ashore from the Wyoming Oceanographic Institution have picked out for us. And we'll go see what we get to see up the top of the hill there. If we can get to this first target in the next 18 minutes, we may just get to see it before I hand over to Paul Tyler for the second half of the dive. So now approaching some rocks in the face of the sediment. We are on a heading of 105 degrees here. We have a steep slope downhill to the left. So we're looking due east. This is actually a more, so it's an east-west spur coming out of the side of the hill. It's my best interpretation, sloping to the north. Extensive biogenic carbonate sediment cover. Some sub-horizontal layers in the rocks. Pilot, can you see just above your lasers, there are actually some horizontal ledges in the rock above and to the right. Could we zoom in on and have a look at those, please? So this morphology we can see in this little Herc view here is less consistent with the blobs of pillow basalts. It looks more like horizontal layers, so it could even be that we're getting into a regime of sheet flow, lava flows here rather than individual blobs. It's basically when you get sheets rather than pillows, it's indicative of faster rates of volcanic eruption, if that is what's causing this layering. Okay. Is Sirius coming our way, though?
Yes.
Okay. Another one of those little indentations on the top.
Sorry, that is not moving. Oh, I won't float out here. I'll go investigate something behind me. Okay.
And now when we do get up to those rocks, probably we'll be ready to drop a marker when we get there. Thank you. Thank you. And so, you know, at home, we're basically the ship hasn't started moving yet, but the direction we were looking just now when we were looking at the those layered rocks is actually the direction the ship and Sirius are going to be moving. So we're going to come back and look at those in a moment. But because there's a certain amount of inertia in getting things moving, we're just going to wait until everything's going to come closer. We'd be at the end of our tether otherwise, trying to reach them.
As recall, just to the right, I was requesting a little bit unknown, just not a technical line.
Actually, pilot, if we could just spin left and look at those layered rocks that are just bottom left corner, is that possible? Yeah, I think just a little left of your lasers there, there's like 3 horizontal slabs. Just left of your lasers now. Great.
Yeah, Chris, can we zoom in there?
Yep, just doing that, Mike. So if you could zoom there, please, pilot. Thank you. We are now on a heading of 238 degrees. We're at a water depth of 2146 meters. And now if we could just drop a waypoint quickly, please. That should be 102, MCR 102.
Spin around and get this done.
And so, you know, at home, what we're going to do is do a quick 360 and undo the twist in the tether.
Okay, so back up and look at that.
Nav,
So I
bridge.
think they're just to the right of your field of view, pilot.
Our heading change is complete.
Spin
Copy
right,
that.
and just
Remind
under
me
your
of
lasers, just off to the right now.
It's 130 meters, 110 degrees, 0.2 knots.
Okay, I'm starting that now.
That's great. If you could,
Ship's underway.
can we get spin a little right and zoom just there? Actually, I can see another set of nice rocks around to the right of the lasers there. If you just go due right, there's a block with a lot of layers in it, horizontal layers. And it's that's it. Down and to the right. And for any kind of clue in the texture on the dark rock. Can we zoom any further? How's that, Mike, if you're watching at home? Is that looking good? The heading right now is 355 degrees, depth of 2145 meters. 10 centimeter there, so those are less than 10 centimeter intervals between the layers. Thank you, pilot. Okay, time to get ourselves underway. The ship has got some momentum to it. It's on its way, and we're going to follow. Just looking on the sonars as we head towards the cliff. Nothing on the Sirius video. A crater dead ahead on a heading of 07, well, Little Herc's looking on 074 degrees. So it's sort of due east of us. Sirius is heading on a direction of 100. Nav, is this the same hole that we flew over before, or is this a new location?
No, this is the same one.
Very good, thank you.
This isn't the round hole. No, but this has been going. Yeah, and then it cut out over. Yeah.
So we already have a marker here, is that correct?
No, we were waiting. Had not dropped one here. I was waiting at the edge of that wall. Unless you want one.
I remember, yep. We were going to get across the far side and look at the rocks.
Pretty much 102.
Yep, understood. That's where we just looked at the last set of rocks.
Correct.
Thank you. Just got myself a little bit disoriented there for a moment. Must have been that fast spin, I went dizzy. There's always time to look at pretty coral. Oh, there's a little shrimp swimming around there, just disappeared out. And there's a little shrimp, look. Oh, that's a beautiful shot. That's a definite happy hippie moment there. Sucked in down the spiral, shot out the other side. Well, that was that spinning, doing that spinning 360 in the ROV just now. And that is a Gorgonian Iridogorgia. Gentleman in the front row. I thought you'd like to know that. That's input from Santiago Herrera, who's watching and listening from Woods Hole. Thanks, Santiago. Quite beautiful. And on top of that, a coral nobody else on the planet's ever seen before. Nobody's ever been here. Nobody's ever looked. But every coral deserves its 15 minutes of fame. you want the lasers off with that video? There we go. Copilot, I don't need the lasers on if you want to turn those off. Okay, looks like Sirius is actually catching up with Little Herc, so it's time to pick up the ROV and get heading on our way again. We haven't quite finished crossing the terrace yet, but it's going to soon be time to start climbing uphill again, get up to the very top of the hill. So, this is it, gentlemen. You have 4.5 minutes to find me a vent site before it all gets handed over to Paul. So no pressure, but let's get across to the base of that fault. All I want to see is a big cliff coming down, fluids coming out of the intersection, trilobites. Yeah, let's do that, actually. Let's limit those layered rocks, I think, just parallel to the top of your screen. Maybe if we can get lasers back on, please. So we've got these. That's good. Directly above the lasers there. Let's get those in the field of view and zoom in on that. So we are now on a heading of 145 degrees. Nav, I'd like to drop a marker here. Should be MCR 103. MCR 103 confirmed. So we have layered rocks, sub-horizontal, in the hillside. This is the basically coming up, we think, to the hill we're going to climb. Can we just zoom out a little moment, please? I lost them too. I was busy typing and. Are they behind us, huh? Oh yeah, it looks like almost like a vertical face from the Sirius view. And it's got round. So when we get there, our heading is going to change. We're on 148 degrees. That's great. If we can we zoom further wide, please? So we're trying to get my orientation here, what we're looking at. Oh, okay. All right. I'm afraid I've lost my orientation of what it was we wanted to look at. I think they might be up to the right, but I'm not quite sure. Yeah, that was them off to the right. There we go. The ones at the top right-hand corner. Can we get back to those? Do you have some more on the left? How about, I tell you what, let's go up and left, because that's the direction you want to go anyway. I think directly above the lasers there, you can see some layered rock sticking out. Top of your screen, pretty central. There's actually layered indurated sediment underneath there. There are holes in the sediment just due right at the... So we have indurated sediment, and then we have rock on top of that. So it's lithified sediment. Yeah, can we zoom in? Sorry. We want to zoom on those... I think that sediment that's around to the right. We'd like to zoom on that, because if it's black rock on top of soft sediment, maybe we need to stop the ship here for a moment, actually. Nav, is there any chance of stopping the ship and look at this? Okay, have we dropped a marker here? It was very close, right? Let's do that and come back to that. So the reason I'm interested in this is apparently we have sediment here with dark rock on top of it, which is horizontal layered. So we have solid, so an extreme interpretation is that lava has flown out over the top of the sediment, has baked it, cooked it, and lithified it, because we have the layers there. We have sediment underneath rock. Either it's been flipped upside down, or the rock, if it's lava, flowed out over the top of the sediment. So that's something we're going to stop and take some time to look at. I'm due to get kicked out of the chair, but it's going to take about 10 minutes to set up anyway. If I'm talking absolute nonsense, it'll be time for Mike and Bobby to from Wyoming to let Paul know that, and we'll keep going. But for now, we're going to set up here and have a look at this in some detail. It's a potentially very important relationship. Okay, and with that, one last thing for me to get excited about. Understood, pilot. Pilot and nav, so you know we're just changing out the watch lead now while you settle up, and Paul will be in the chair when you come back to this location. Thank you. Yeah, that's correct. It was MCR103. I did call out the heading and the depth, but I don't think we've got it in the event log, I'm afraid.
Let's just check. Okay, the pilots think they've got it now. It's just in the screen. I think this is it on the left.
That looks good. The heading would have been the same as the direction we were going with the ship, which I think was something like 130, maybe?
It was 110, I think, Chris.
Thank you. And what's our heading right now?
We're
spinning too fast.
Hang on. Watch leader here.
That looks like it right there.
Yeah. Thank you very much. Now that's perfect.
Just below the lasers now.
Just below the lasers. If we can go down all over this very, very carefully, please.
It was the sediment layer just disappeared out the bottom right field of view.
Yeah.
It's got little dark holes in it.
What I've asked for, folks, is to have a video all over this patch. That looks pretty layered rock to me, and that looks sort of sedimentary rock underneath, but yeah. If someone can note.
And it looks like you can continue up to the left in this image beneath the basalt. So it's looking good, like sediment beneath lavas.
Okay, pilot, is Paul here. Up to the left, top left corner I've been asked for, please. Yeah. Bobby, we have a little bit of current here as well, so there's a little difficulty, but it's okay. We're bang on MCR103 here. The heading of the ROV is 192. If someone could note that, please.
Got the heading, Paul. Can you get the depth as well, please, for the ROV?
The depth is, I can't see it from my glasses, aren't good enough. 2146. 2146.
Great. And just below the lasers, oh, just actually under the lasers now, looks like there are little hollows in the sediment.
Got them? Yeah. Just getting this video and going closer and go back up once they've got this bit of video in. Is that okay for you, Bobby?
It is. When we can, if we can pan very, very slowly to the left.
If we could pan slowly to the left, please, pilot.
And then maybe zoom in right here.
Can we zoom in, please? Hang on, please, Bobby. They're going to go round and try again and have another go. They want to improve that. Oh, there's a skid mark. That's good. We do. It was sheer slope there. Bobby, do you think that could have all crumbled away? All the what looked like lithified fine sediment has crumbled away to form the slope?
It's possible that this is just a buttress unconformity of sediment? Yeah, that's basically just deposited against the lavas in contrast to being interlayered with it. And then, as you say, Paul, some of that's been eroded away, and so we just have these little relics sticking on. It's really difficult to tell, though.
Yeah, not kidding. As a non-geologist, this is pretty challenging for me.
As a geologist, it's pretty challenging for me.
Oh, that makes me feel much better. That certainly looks like layered solid stuff to me, and with the sediment sort of coming down through it.
And now I think we want to go down a tiny bit.
Can we go down a tiny bit, please? Any more, Bobby, or is that okay?
I'm still trying to find in the big picture where the sediments are, because these are just things that, stuff that's rained down on top of the lavas. I'm still looking for the more layered sediment.
Do you want us to zoom out?
Yeah, if we could, just a little.
Zoom out a little, please. Yeah. Oh, we're full out at the moment. Okay, tell me if you want to go in. Okay, this is where we've been videoing just now.
Right, so there's the sediment just to the left of the lasers.
Yeah.
And that kind of, I can't tell if it looks like it's just plastered up against it or not. Maybe Chris has a better view.
Do you want that to fill the screen?
Oh, this is a good vantage point right here.
Okay, we'll carry on like this. This is good. This is good, guys.
Yeah, and so if we just kind of noodle around here very slowly to the left.
Okay. Very, very, very slowly to the left, please. We're just drifting, Bobby. This is it. This is the environment taking us at the moment from what I can make out.
Cool. The environment's doing a good job taking us where we want to go.
I'll tell the pilots. The environment's doing a really good job. When we get to that sedimentary slope, do you want to come back to the right if it's possible to go in further, or is this good enough for you?
Just let us continue to drift a bit longer and then we'll see what it looks like.
That's just fine by us.
Can we zoom a little right under the lasers right now?
Say again, please.
Zoom now where the lasers are.
Can we zoom where the lasers are, please? That okay?
Down a little tiny bit.
Down a tiny bit, please. I think we just run out of. Going to have a third look now, Bobby. They're coming round.
Actually, this angle's quite good too.
Hang on a minute, please. Say again.
Never mind, we just passed it.
It's fine. Either way. I'm good either way. Yeah, I guess you can go to medium series. Is this the spot?
Yeah, I think moving off to the left from here, wasn't it?
If we could move very slowly to the left, that would be great.
Yeah, the request is to move slowly to the left, be perfect. Do you want any tighter zoom, or is this the right? Do you want to go in any closer?
No, let's just keep it at this.
This is perfect, guys. Oh, sorry. This is perfect, guys.
Look down about 10 centimeters, please.
Can we go down about 10 centimeters, please?
Okay, we should swing around to the left, and then after gaining that photography, I think we've got very nice photography, and this might be something that we need to look at very carefully on the beach later.
Okay, if we swing very carefully to the left, please. Now I think that'll complete the video they want, and they'll have to look at the video carefully on the beach later. Yeah, Bobby, we're just about done with time by the sounds of it, listening to the pilots.
Okay, then when I guess I'd say then let's move on.
Okay, I think we'll finish this this section across here. Oh, drifting back the other way now.
So these are the sediments, but I really honestly can't tell if they're just banked up against the lavas or they interstratified.
Yeah, what we're trying to do, chaps, is to see if the lava and these sedimentary layers are interleaved with each other. So, I guess this looks about the right power.
Yeah, no, this is good. The interesting thing is that the sediments between, in essence, between the lavas, whether they're interstratified or just banked against them, do look somewhat more hard, or they're less easily eroded.
I see what you mean, yeah. If they don't, between those two darker layers, where the two holes are, they don't look nicely deposited to me. They look as though they've almost slumped into there.
Yeah. So when the pilots feel like they'd like to, I think we've got the footage that we need to look at the beach carefully, and so we can move on to the next sort of bit of action.
Thank you very much, Bobby. Paul to pilots. Okay, I think we're done here. They're going to spend a lot of time really poring over that video in the future. That was really good. Well done, chaps. Okay, we're leaving the current station, which I think is near what today's waypoint 3, and moving off to 4.
It was marker 103, Paul, and we're on our way uphill to E04.
Yep. Just making sure. Yeah, so we'll be moving off to the generally direction of the southeast now, and it looks as though we have a steep slope to go up, and then we'll come out to the highest point at E04, today's highest point on top of this particular peak, and we'll just see what we've got there. But at the moment we have a lot of sediment as we're moving over the ground. And it's not, though, when you look at the chart, it doesn't really look that flat, but that's steep, but it is actually really quite steep. Though it looks as though we're on a terrace here.
Go ahead.
It's a steep,
100 meters,
sloping terrace.
105 degrees, 0.2 knots, please.
For those of you that have tuned in from home, this is the Okeanos Explorer working in the Cayman Islands Exclusive Economic Zone, working over an area called the Mount Dent in the Mid-Cayman Rise, and we're using the ROV Little Hercules to look at the seabed at approximately 2,000 meters depth. What you can see in the screen here is moving over a sedimentary surface on a peak that at the moment is named Europa, and we're just waiting to move off in a direction of 0.15 and then to 105, and then moving towards the southeast, and we'll be going upslope. The time is coming up to 18:30 UTC or Greenwich Mean Time, whichever you prefer to use. The Xenofire 4? All right. Okay. The Xenofire 4 is a large single-celled organism. It's a protozoan. It has only one cell body, but it often has a number of nuclei within that body. And it lives on the sediment surface with part of the tissue of the cell, that is called the protoplasm, is buried in the sediment. And it takes in particles like, those of you that have done school level biology will have studied the amoeba. And just think of a sort of a giant amoeba taking in particles, and this, it sort of builds up sometimes a very delicate structure within the cell, and it digests these particles of organic matter and then deposits the waste. The structure is called stercomata, and these are deposited in this wall, and it forms these very distinctive, almost little wavy-like structures. One of my colleagues at Southampton specialises in these, and he will spend hours carefully looking at one before he even touches it to try and understand it, because the shapes, have to be looked at very, very carefully. And they appear to occur particularly in deep water. We don't know of any in shallow water. And the place that we found them very commonly is right down at the bottom of submarine canyons. There's a place off Portugal, 3,400 meters, where they're 10 every square meter. Really, really common. And no, not that concentrated at all. When we've dived in the Portuguese canyons, the Nazaré Canyon, we found them in very high concentrations, and you could just see you just look across this flat seabed, and there's just nothing else there. And it appears that they're quite important in the carbon turnover at the sea floor. The surface production sinks, and we know holothurians eat it, and other animals eat it as well. It also appears that the xenophobophores recycle this organic carbon at the sea floor. Sorry, I didn't see it, but it could well have been. I've seen a few as we've been going along. Some of them almost look like a honeycomb structure. Oh, that could be one there. Bottom right. Yeah. That looks like a xeno. That certainly looks like one. If you want to zoom in on it and have a look. Yeah. Oh, there we go. Gotcha. Yep, that's a xenophobophore. As I say, it looks like the honeycomb structure, and that is a single cell. And as you saw with the lasers, I wasn't quite sure, 5 to 6 centimeters across. It will have parts of the cell going down into the sediment, and you can just find huge areas of the seabed where these are very common. And the real problem was initially when these things were collected, by trawl, they just get smashed up and you get fragments of them. And then they started being collected in cores, and now with using ROVs, we can collect them very, very carefully and bring them back to the surface intact. And in some cases, still living. But it's one of those things becomes a debate as to whether these things are actually living or dead, because if the protoplasm dies, the structure stays intact. And so we're never quite sure whether they're living or dead. Yep. When one gets one's eye in on these things, suddenly they're all over the place. Okay, we're moving out across a flat terrace here, relatively flat terrace. More of these gouge marks. And as we know now, there's some nice xenophobophores occurring on this area. Not much else. We actually haven't seen a holothurian for some time. And having said that, the pilots see a holothurian. There's several of them. They've just been waiting for us to arrive. But interestingly, all those trails that we've been seeing, I've not seen any of them associated with one of these holothurians. so it's something else that's causing those trails. And it looks like something that's rooting through the sediment to push the surface sediment to form a sort of little levee either side of the main trail. And I'm not sure that's how the Holothurians move. They tend to use their tentacles almost like a hand, picking up handfuls of sediment and putting it in the mouth. If you look at the tentacles around the mouth of the Holothurian, you get some that are feather-like when they're filter feeders, but these ones at the deep sea floor have what are called peltate tentacles, and they have these flat areas, like a series of fat fingers around each tentacle that goes onto the sea floor, and the particles of organic matter stick to the peltate tentacles, and then they're sucked off by the mouth.
I'm not sure, Paul, this is video, but I believe yesterday I saw one of those trails just out of the corner. I believe I saw maybe a really clear sea cucumber. Find out in the video.
That I will look at that. That will be really interesting because I thought it'd be a sea cucumber or a sea urchin that would form those trails. Yes, we're lucky. This particular sea urchin we're seeing very commonly is pink, and we're seeing it's because it's pink. But sometimes they're almost translucent, and I suspect there's also some sea cucumbers buried in the sediment here. There are certain types of sea cucumber that appear to farm in the organic matter in the sediment. Okay, we're working our way across this terrace now. We're getting to the southeastern edge of the terrace. It should steep perceptibly. Still no hard echoes on the sonar. Okay, on our way again, moving towards the southeast. Going uphill the whole time. I'm expecting it to get steeper quite sharply in the not too distant future.
Wanted to work with it.
Go ahead.
Yes, can I have a move 165 meters, 125 degrees at 0.1 knots?
Okay. I have 165 meters, 125 degrees, 0.1 knots.
That is correct.
Starting it now.
Again, more bioturbation. There's still that sort of darkish colour look to the sediment. So there's lots of those sort of dark grains in it. Yeah, look at the bioturbation round here. This is interesting. Hi, Nav.
Paul, this is Jill at OSEC.
Hang on, Bobby.
Do you
Just a
think we
second,
could?
please. Please repeat, Nav. Go on to E5. Depending on what we find at E4. Is that okay?
Yeah, that's good. I just
Yeah.
wanted to get it.
Yeah. Sorry, Bobby. I was chatting to the Nav. Bobby's.
This is Jill here, but
Oh.
Bobby's requesting if we could just take a quick zoom on the sediment here, just to see if it looks any different.
So to take a picture. You said, what did you want to do?
Zoom in on the sediment, please,
Okay.
Paul.
Can we zoom in on the sediment, please? Yep. They want to see if the sediment's different. I thought the sediment was coarser here. This looks interesting. Yeah, shall we stop and just have a look at this? Now, Chris, what do you think this is?
I really can't see from this monitor. Shall I come down and take a look?
I think it's just a little pile of stones covered in coarse sediment. But it doesn't give me the feeling of hydrothermal vent. Could just be sponges that have come down. But if we can get some closer, if we can get some video of the sediment, that would be very helpful. Pull to the beach. Tell me when you've got enough. It's very coarse, isn't it? I can see pteropod shells, what look like worm tubes. Those tiny thin tubes might be another form of foram. There's another single cell organism called bathysiphon that produces little tubes, little sand grain tubes in sediment. And again, it's very, very common in the deep sea. Gah. Ah, yeah, I see something solid ahead. Is that okay? Was that Jill I was talking to? You can see how steep it is here, just by as the camera panned left there. It must be 45 degrees. I'd have thought the slope here. This looks like quite a large rock band on the sonar. I think we should try and. It looks very sediment covered, so I'm not sure we're going to see much structure in it. Jill, are you still on the phone?
Yep, right here.
Do we want to try and get some close up here? It's so sediment covered. I'm not sure you'll see any of the underlying fabric at all.
Yeah, we agree. This is a good distance from that.
Okay. If we can keep going, please.
The rocks might be better if you just pan left, Paul, or is that more sponge?
Can we just try panning left a little bit, please?
No, trick of the light, thank you.
If you look, folks, it looks very impressive in the Sirius camera. There's a real layer coming in, or looks like a layer to me, coming into the top of the Sirius screen. I don't know if you guys can see it on the beach. I'm not sure that's an overhang or whether it's just the way we're looking at it from Sirius. But it's seriously steep. And we're at 153 degrees orientation of the ROV. We're at 2130.
Paul, could you describe the overall orientation of the scarp?
Of the ROV?
If we get the ROV lined up like it is now along that face, what's the heading of the ROV when it's looking along the edge there?
Okay.
If you spin a little bit to the left to get that lined up.
Before we go any further, can we just line up to look right down the length of the face, please, to get the orientation of the face?
And that looks like another one of those 1 meter wide rifts there as well.
Yeah.
That's great. What's the heading now?
71. 71.
Thank you.
Yeah, we haven't got much time here because I think they want to get up to the top of this here cliff. Yes, that was a sheer cliff, wasn't it? That was nice. .2121 at the top of the sheer face. No, but we'll call it, I don't know what we'll call it. No, it is a beautiful coral. They all come under the general heading of fan corals. But as I say, you have to have the specimen in your hand and look at the spicules and other factors, how the spicules close up round the polyp, and it's just not easy to see from in video or in stills. Oh, we're getting up to near the top of our tower, our hill. To the geologist, could this just be a volcanic cone? Silence, was the stony reply.
Hi, Paul. Not sure. I mean, as Chris said in the event log, in some ways there's a lot of similarities to what we were seeing yesterday in that, these would be old fault scarps that were involved in breaking up this volcanic pile. Whether it's part of a bigger cone, the whole bump is a cone, is a good question.
No, because always, we're interested in volcanoes, having found hydrothermal vents in volcanoes at the East Coast Ridge and Antarctica now. I think volcanoes are going to be the new thing for looking for vents. So always happy to look in volcanoes.
Just for clarification, that's an arc volcano, Paul. I don't think we think that's what this setting is.
Oh, well, yeah, maybe I really just don't know enough about geology.
Yeah, I think the cute thing about that Scotia work is that there's where you have a mid-ocean ridge section, the East Coast Ridge, that close to a back arc system, or it's a back arc system close to the arc.
Yeah.
The nearest arc here is probably over near Barbados, I believe. It's a bit more separated.
Okay. Well, when you want to know, next time you want to know which way we're going, Quo Vadis. Oh, can we stop? Can we stop, please? Yeah, we've got time. Because I think... what's happened here? Oh, God. Very nice. This is a sea pen. This is called a sea pen, and it's related to the gorgonians, the big bush corals you see. But if you look at the bush corals, they're normally attached to a rock, like with a gluey bit at the bottom. But if you go down to the bottom of this one when you're ready, you'll find that oh, that is beautiful. That is, it sticks into the sediment. Ah, as a reproductive biologist, I can see the gonads. That is beautiful. Some nice video of this would be greatly appreciated. The dark brown or the dark, very dark red is the gut, and the pinky parts in there are the developing gonads, the reproductive parts of the body. And if you look down at the bottom, if you look at the bottom, you'll see how it goes into the sediment, and it'll go into the sediment, and it has what's called a peduncle, and this sort of swells slightly and holds it in the sediment. Thank you very much, guys. This is very nice indeed. Oh, beautiful. Oh, yes. Absolutely fabulous. Oh, they've disturbed it a little bit, but that was just... Oh, wasn't that glorious? What's that down in the bottom right there? There has to be something interesting in this wilderness. Thank you very much, Nav. Ah, yes, very nice indeed. Very nice. We haven't seen one like that. It reminds me actually of a burrowing anemone. Many anemones attached to rocks, but you get a certain group. One of them goes by the wonderful name of Pichia, and they live burrowed in sediment, and they swell the body slightly to keep themselves anchored in the sediment, and that could be related to that. Beautiful video, really nice. Oh, it's relaxing now. Thank you for that, guys. Well, it looked fairly peaked on the charts, but it's actually pretty flat topped by the look of it to me. Seen a lot of sediment today. We've seen a few rock outcrops and one very steep cliff about 21 meters high. But this is very much a sedimented area. But this is what exploration is all about. We have to tick off the things that maybe are not what we're looking for. And people look for different things for different reasons. Just asking Bobby and Mike, does this contribute to your understanding of the geology?
Hi, Paul. I think what we saw this morning until lunchtime was consistent with our overall kind of picture of what's going on. It's important to basically ground truth that there's basalt on top of the hill, and my guess is those steep slopes were fault controlled, which fits with the overall picture from the bathymetry.
That's great, as long as that's of use. Oh, a pink calatheid. Oh, see his antennae move. He's sensing to see what's going on there. Oh. See? Oh, yeah. I suspect some. To have such large eyes still, with the things that have gone blind in the deep sea, the eye tends to go down very small. The topography, it was going to be pretty flat, because it looks as though it's a shoulder, the whole top of this particular peak, which looks quite elongated, looks pretty flat. Someone's had a party. I'm not sure I'd want to go to a party where there was just one. Can you see the very long antennae? Isn't that wonderful? That it goes by the name of Suggestes, and you can see the swimming legs, and they belong to a group called, or they used to be called, the Natantia. Natantia, which means swimming. Oh, that's fabulous. Oh, I like that. Oh, way. No, that was just great.
Am I chasing this guy down?
RV nav bridge.
Yes, go ahead.
What am I? What are we
30
looking at?
meters left in the move.
54.
5
right.
minutes.
Okay.
Come ahead. Thank you.
See? Swimming shrimp. Yeah. Yes, Suggestes, it's easier. No, guys, the sheer pleasure of this sort of thing is the first 10 years, every sample I saw of deep sea animals was from a trawl dumped on the deck on the stern of a ship in the northeast Atlantic, and not in always particularly good condition. To see something actually in situ swimming, fantastic. That would be, that would be about right, 6 to 8 inches. Yeah. Some of them are fished commercially in the Mediterranean, not the same as that species, but they're fished commercially off Barcelona.
fine. You're good spot. You got another couple minutes if you want. Okay. Alright, well.
No problem. It's the first hermit crab I think we've
Harvey
seen.
Nav Bridge.
Yes, go ahead.
Waypoint achieved. Beginning of the next move.
Okay.
Keep an eye on the sun. There's a white thing. There is a. Just a little bit on the left. Drive it a little bit. What's that white thing?
Let's have a look. Let's have a look. It looks the other half of that nautilus shell. Oh, isn't that beautiful? Oh. It's times like this you wish you could pick those sort of things up as souvenirs. That was beautiful. Guys, I think you'll find it very delicate, and I think the skid would most likely turn it into fragments. Nothing, that's not a comment on your piloting abilities, by the way. That is just splendid.
Alright, guys, going up. Gee, that's pretty.
Isn't it? I would have thought we could have got that down to what the original species was.
Yep. There seems to be a shadow on the radar right ahead of me. Okay. I'm pointed more or less in the correct direction. If you just push ahead. Okay. Get back out in front of me a little bit.
Hi, Paul. This is Jill at OSEC. We are just wondering how much more time we have on bottom.
Oh, say again? How much time we have on? We must have another hour, I think, at least.
Okay, thank you.
Actually, we have an hour and a half.
Okay, great. Thanks. So now, are we heading for waypoint 6?
We are heading for waypoint 6.
Paul, this is Chris. I'm about to head out to an operations meeting here on the ship.
Thought you might be.
But I think if we get to waypoint 6, what I discussed with Dave Lavalvo last night was when we get to the southernmost point, I think that's E07,
yeah,
we can probably drive out into deep water and drop down onto E08 and then contour north to E09.
That's what I was planning on doing.
Very good.
Yep. Okay, babe. I'll catch you when you get back from the meeting.
Thank you.
Harvey Nav Bridge.
Yes, go ahead.
90 meters, 10 minutes remaining in this position move.
Thank you.
Now, when we get to waypoint 6, I'd like to take a marker fix, please. Agreed.
That's the direction we're going. Okay. Go ahead, zoom if you want on there now. Looks like a stick to me. Is there another camera? There's a fish right there too. That should come out. Little one. Concrete buffalo or whatever. Yeah, those sticks are unpredictable. Stick. Yeah.
That is a very interesting point you've just made, guys, because wood is a very unpredictable resource in the deep sea. But what is really interesting is there is a group of animals that go by the name of xylophaga, which means wood eating, that live exclusively on wood in the deep sea. And it's one of the groups of animals that Diva is working on as part of her PhD.
They must be extremely opportunistic, because how could they ever know where their next meal was going to come from?
That's exactly right, and they tend to occur in areas where there is a spring thaw and trees are washed down from upstream in the spring thaw, or in areas where there's hurricanes and trees are bent in hurricanes, washed offshore and sink. But you're right.
Paul, can we spend like a minute looking at it, if possible?
Can we spend some time looking at it, please?
We've got a little bit of time here, yeah.
Yeah.
Sorry about the dress.
Yeah. Okay. So, please take video the whole time, and if it clears, nice bits of the whole wood.
Can you zoom out a little? Sorry about the dress.
Was that you, Diva? Diva, speak to me.
I don't know who's going to clear before I...
No, that was me.
If we can get what video we can, that would be very useful. Right from the very broken end along it would be just great.
Paul, that was me. Hello.
Oh, yeah, where you disappeared to? I'm just wondering if you can see. Sometimes you can see the siphons of xylophaga sticking out of the wood, but this I think might be bamboo, is it? Rather than
It looks like bamboo, and I can
yeah.
see isopods.
You can see isopods.
But it doesn't.
Yeah.
I can't actually see any siphons.
No. But it's a nice little habitat.
There are there's lots of life on it.
Yeah.
Anyway.
We're on our way. Sorry. Tell the truth, in this desert,
Thank you.
A lump of wood is, is really interesting.
Coming up on it right there. I see it. Big hole in the ground. Wow. Yes, sir. Now fly a little to the right. There's the next one. Oh, there we go.
I'll tell you better when I can see it. It looks like, I'm not sure. Crinoid, yeah. No. No. Wow. Oh, it's a cereanthid. That's a cereanthid. You can see the tube on the bottom part of it, and what we should see is two rows of tentacles. Normally the outer row much longer than the inner row, but it looks as though there's two rows of tentacles of roughly either equal length then. Oh yes, that's beautiful. That's yes. That that looks as though it's got 3 rows of tentacles, 2 long ones, and the short ones at the bottom. And it has these lovely lazy arm movements, or tentacle movements, I suppose they are. And I presume they're picking particles out of the water column. Then they move the tentacle towards the mouth, and they sort of suck the tentacle and take the particle off. Very nice. That's that. That's absolutely lovely video. Wow. Oh yeah. It looks a pretty lazy existence to me. You can see the tube very nicely to the right there. Again, these are very difficult animals to sample within the deep sea because the tubes go quite a way into the sediment. And if you're trying to trawl over them, what you do is you just flatten them down, trawl goes straight over them, and they bounce back up. So in the past, we found that the data from trawling and the data from video sledges and things like that just do not match. Quick look, please. Quick look, please. Thank you, guys. I can't see any siphons sticking out, and it actually looks in reasonably good condition. That sort of piece of wood would disappear, I would have thought, within a year, certainly 2 years of landing on the seabed. To tell the truth, in the past, Diva, when we've had a lump of wood that we've got xylophaga in, we've had to get it up into the lab in seawater and under a microscope to see the siphons. But there's some holes there that may well have been bored into. See the two holes, one bottom middle, one top just right of middle. They could be nail holes, of course. They might be bore holes as well. And there's other ones down the side. I suspect that most likely if you broke that open, you would find xylophaga. Oh yeah, look, there's lots of holes along there.
But I've seen pictures from Craig Smith that he put down off California, I think, and the siphons was huge, and you could see them from, they just covered the entire piece of wood.
Yeah, I would, we've never actually been able to look that close because we've always had still cameras with the Johnson Sea links, but we could have disturbed them when the sediment was moving about. It's interesting to see wood. I shall certainly use a picture of this in my lectures on xylophaga.
Those holes could always just be from normal pteridinids that were attacking it before it sank into the deep sea, I guess, as well.
Say again?
Those holes, I'm guessing, could also just be from pteridinids that attacked it before it sank.
Yeah. Okay.
We will never know.
It's much easier doing it experimentally with wood. Okay, we're heading towards 07 now. Underwater woodpeckers. Oh dear, Chris German's being witty. That looks like another one of those penatulids. That would be cool, yeah. Okay, we stopped to look at this penatulid. I think it's a penatulid. Tell you better when we go in, but I'm pretty sure it is. Oh. Yeah, that's lovely video. Perfect. If you could come out just a little bit. Oh, fabulous. Now this is really interesting because if you look at the way the polyps, the big polyps are arranged, the autozooids, they're actually on one side of the stem. And when we zoom in, if you look at the side facing us, you'll see little structures that look like holes, and they're called siphonozoids, and they actually run water through the coelenchyme. Can you see the white blobs on the stem there? Those are the siphonozoids, and they are highly modified polyps that drive water through the tissue that makes up the body of the animal. Thank you, Pilot and Video. That was very nice indeed. Chris, far away.
Yeah, it's got a line from Bobby that when they look at the facts of it, the waypoint E09 is better target than E08. So if you've only got an hour left, then when they get across the rail here, everything else should go very, very.
Looks looks like a sack. Oh no. Whatever it is, it's been there a long time.
Nav bridge.
Stand by. Sorry. Yes, go ahead, Rich. Bridge nav.
20 meters remaining.
Thanks.
Yes, Nav.
Yeah, so I'm preparing for the move, and it's going to be, we're not going to make the move, we're not going to finish the move because it's 0.7 kilometers, and 113 minutes. So we'll
Oh.
back up in
Okay. Yeah, it's the destination, the interest.
Okay, then what we can do, we can go much faster.
Yeah.
Lose contact with terrain. So you have to
Yeah.
decide whether you want intervening terrain.
Go up into the water column. Okay. Bobby and Mike there. Is Bobby there, please? Hello, Rhode Island.
Hi, at OSAC, Bobby's here, yeah?
Okay, it's Paul here. It would be 100 meters to EO9 if we went along the seabed. So I've said that as that's an important site, we're going to go up into the water column and hammer across there fairly fast. And then we'll drop down on E9 and we should get some time there. Is that acceptable?
Yes, that sounds great.
Oh, sorry, 100 minutes it is, not 100 meters. Thank you for looking after me, Roland.
We don't have 100 minutes, do we, Paul?
No. Oh, you're back, Chris. It was going to be 100 minutes if we went along the seabed. And so as that's the target was more important than the drive, I've suggested we go up into the water column. They'll get across there really quick. We'll have a time to look round there.
Yeah, that's what you and I discussed before. That sounds
Yeah.
great. We
Okay,
go
mate.
as quick as we can.
You're happy about that?
Very much so. Thank you.
Okay. That'll take 23 minutes to get there in the water column. We'll have about 45 minutes there, Chris.
Excellent. Thanks, Paul.
Nav, are we on 07 now? Thank you. A guide to how you go about trying to solve the problems of science. Whether we should go back to find the origin of life could be another philosophical question, but I think we will be able to come up with a theory of the origin of life. I don't think we'll ever be able to prove it ultimately because we're not even sure whether it happened once or twice or a dozen times, but only once does it appear to have been successful. And so there might be different mechanisms for the origin of molecules that interact together to ultimately form a tissue or something like DNA, but only once did it work its way right the way through to come through to what we have today.
I see seafloor.
Okay. And I see mud. Oh, Chris's comment.
There was something lumpy to the left there. I was spinning around the other way. Sorry. Was that layered rock there?
We're starting basically on the southwest corner of the 2,160 meter contour and going up slightly to the target.
Could you give us our depth and heading, please, Paul, for orientation?
Heading is 91. Depth is... Oh, I can't... Depth will be 2,160.
Thank you.
Well, guys, it looks the same sort of scale as on the bed, but you made it. That's fantastic. It can be done. We can do it. Well, you could do it. I just sit here. Now, the last bit of magic I want from you guys today is a vent. I'm not picky. Just a nice gentle flow would be lovely. Thank you very much. Can we just look round, please? In all directions. Mike and Bobby, was this what you were expecting, or were you expecting something a bit more exciting?
Hi, Paul. I got delegated to come across. I'm not totally surprised. If we've got time to drop down off the side, we might see pillow basalts like we saw before.
Which
but at least we've checked out.
Which
but
direction?
At least we've checked out. I would go north because the backscatter looks a little brighter. But at least we've checked out, the top of the dome. I mean, I think that's an important thing to do in itself, to actually know that it's sediment on top.
Pilots, could we go north, please, until we run out of time? Okay, Mike, we're going north till we run out of time, which won't be very long. Thank you, guys. We really do know we need never come back here. No, nothing at all.
Well, I don't know if this is a gentle horizon or a sharp horizon, so push out to the furthest.
Apparently, apparently there was good reflectance on this north side in the backscatter, so that's why they're interested in having a look over here. So we might just drop over a precipice in a minute, but I'm not convinced. Chris is suggesting we pull out because we're not going to gain anything more in terms of knowledge here. I don't think. I think we're just going to be going round for the sake of going round. I don't know what you feel. Chris, private line. I think we're just going to be just going around looking at sediment here for the next half hour. I think we should pull out. Yeah. Yeah, we're done. Okay, guys. Excuse me. Okay, guys. I think we're going to pull out. I think it's just sediment here, and I think we need to call a termination to this dive. We don't need to come back here again. Yeah. Thank you very much for your efforts today. We've really looked hard. We've seen a lot of sediment, we've seen a little rock, and we've seen no hydrothermal vents. But that's part of exploration.
Sure.
Right. Well, it was a good exercise to get that tall maneuver. Yeah.
Oh, that's great. Great.
Training for the team here, and we did manage to land on the spot just in the nick of time. So we'll have that in the bag for the future.
Nav, dive super status, please.
Yeah, Little Herc is coming a little bit to the port side, maybe 30, 35 degrees, but look good to keep coming up. Winch is all stopped. Both vehicles are, well, Sirius is at 50 and Little Herc is coming up at 58 right now.
Roger that. Dive super will take over the comms now, please.
Roger that. You have comms.
Bridge, dive super status, please.
Dive Super Bridge, we have control of the aft station. We're doing about a knot through the water. Current is about 176 at 0.6 knots. And we're ready for you to bring up.
Roger that. Winch, dive super.
Dive super winch.
Yes, could you pass control of the winch from the control room to the O2 deck, please?
Transferring control now.
Confirm.
Roger. Confirmed O2 deck has control of the winch. Pilot, dive super.
Dive super pilot.
You guys ready to come up?
We are ready.
Roger, stand by. Bridge, we're ready to come up.
Roger that. You can.
Roger that. Coming up 15 meters a minute, please.
15 meters a minute.
Yeah, sure, I'm not using that camera at the moment. It's all yours.
Passing 4040.
Roger, 40 meters.
Passing 3030.
Roger, 30 meters. Hey, Dick, would you remind people that we're on film and that doing things with gestures and things like that are not appropriate?
Copy that.
Passing 2020. Passing 10.
Roger, 10 meters.
ROV 12 meters coming up.
Roger that. Carl, you want to secure your thrusters before you actually hit the surface, okay? You got a lot of grass up here.
Copy that. I'll secure them at 3 meters.
Roger, thank you. Vehicle's in sight.
Thrusters secure.
Roger.
video to dive super?
Go ahead.
We're getting some excellent video at the moment on some fish and sharks immediately in front of the ROV. Just FYI.
Roger that.
Daisy chain is free of ROV.
Roger that. Thank you.
And the lift line looks clear, it's just taped on.
Roger that.
Lift line is clear.
Thank you.
Daisy chain is free of ROV.
Roger that. Thank you.
And the lift line looks clear, it's just taped on.
Roger that.
Lift line is clear.
Thank you.